Welcome back after a long theory section, which I hope was really helpful. Now in this one, we will basically continue learning about basic JavaScript features and syntax, but this time with a focus on more modern JavaScript. So we're gonna dive deeper into built-in data structures like objects, maps, and arrays. We will talk about modern ES6+ operators such as destructuring and optional chaining, and we will also take a look at how to work with strings. And all this together will then give you a very solid and important foundation for the upcoming sections and projects. Let's start this section by learning about array destructuring. So as I said in the intro video, in this section we're basically going to continue learning basic syntax and basic JavaScript features, but now with a focus on more modern JavaScript. And the theme of this section will be to simulate a food delivery application, and in specific one Italian restaurant, which is this starter data here that we already have in the starter files. And so this one is called Classico Italiano. So I already opened up the starter files here for this project, okay? Now, learning complex topics like the ones we're gonna dive into in this section is really best done in isolation. This way you can understand exactly what I'm trying to teach you without having to think about 5 other things at the same time. And so I'm isolating just this one restaurant and building no user interface so that we can focus just on the JavaScript language here. And some people will say that this is boring, but believe me, I do have enough teaching experience to know that some topics are best learned in isolation. And for me, the most important thing is that you will actually learn in this course. Now, of course, there are also topics that can be applied to a visual project. And that's why in the next section, we have a really cool project with an amazing user interface where we're going to learn about array methods. But for now, let's focus on built-in data structures and modern advanced operators. And again, starting with array destructuring. So destructuring is an ES6 feature, and it's basically a way of unpacking values from an array or an object into separate variables. So in other words, destructuring is to break a complex data structure down into a smaller data structure like a variable. So for arrays, we use destructuring to retrieve elements from the array and store them into variables in a very easy way. So let's just actually start with a very simple array. And now if we wanted to retrieve each one into its own variable without destructuring, we would do it like this. Let's say we wanted to name them A, B, C. And so we would write the name of the array, which I totally forgot up here. So R0, and then just duplicating this line, which I'm using Command or Option L for. And I'm not sure if that is actually a shortcut in VS Code. Let me see here. And apparently it's not. Let's see here. Duplicate selection. So it's this duplicate selection here. And you can set up a shortcut for that. And so I will just do that. So B, and so that would be element number 1, and number 2 would be C. So that's how we would retrieve these 3 elements. But now with destructuring, we can actually declare all the 3 variables at the same time. So let me show you how. So const, and then we use the square brackets. And so that's because we are destructuring an array. And so now we can declare 3 variables at the same time. And now I'm not using A, B, and C because we already used them. So let's go with X, Y, and Z. And then I will simply set that equal to the array. And that's it. So let's actually see them now in the console. give it a save, and then we need to start our live server with a new terminal. And actually I can hit the tab key now, and it will then automatically write the rest of the command. Then close that down. And as you can see, here we get the two results, 2, 3, and 4. So the elements of the array. So basically, we write this syntax here, and then this will become the first element of the array, this the second, and this the third. And so this here is destructuring this array here from the right side. Okay, and of course, this looks like an array, but it's really not. It's just the destructuring assignment. So whenever JavaScript sees this here on the left side of the equal sign, it knows that it should do destructuring. Now when you do this, just don't forget to actually also declare the variables using const. Okay? And I also wanted to notice that even though we did destructuring, which sounds kind of destructive, right? The original array is of course not affected. Okay, so we are not destroying here the array, we are only destructuring. So we are unpacking it. Okay, and now let's work a little bit with the data from our restaurant. So here we see that we have a couple of arrays here actually. So the categories, the starter menu, and the main menu. So let's take some elements out of the categories. So let's say, and then the destructuring assignment, first and second. All right. And so now you see here that we do not have to take all of the elements out of the array. So this will just take the first and the second. So it will simply follow the order of the elements here and will basically only take these two. And so now the array from which we want to extract, and that's restaurant.categories. Just to take a look now. And indeed, we get Italian and pizzeria, which are exactly the first two elements of the array. But now let's say that we only wanted to take the first category, so this one, and the third. So let's say that this one is the main category and this is the secondary for some reason. Well, to do that, we simply leave a hole in the destructuring operator. So what I mean is just this. And so now the second element will be skipped, so the one that would go here, and then this second here simply becomes this third element. And now, so you see that second now is vegetarian, which is element number 3. All right. And so like this, we don't have to create variables for all the stuff that we might not even need. So if we only need to take this and this, we just skip the element in the middle. Okay. And this is really powerful, and we use destructuring to do a lot of cool things. For example, let's say that the owner of the restaurant now decided to switch the main and the secondary category. So right now the primary is Italian and the secondary is vegetarian, but now they wanted to switch it. So let's first change the name here to main and secondary, just to make it a bit more obvious. Secondary. And so if we would like to switch these two variables, then without destructuring, we would have to do it like this. We would need to create a temporary variable, and then to that we would assign one of them. So let's say main, and then we could switch main. We would say main is equal to the secondary, and then secondary is equal to temp, because that's where we temporarily stored the value of main, right? We could not just do main equals secondary and then secondary equals main, because by then we would already have overwritten the main variable, right? And that's why we need this temporary variable in the middle. So that's how we would do it. But with destructuring, we can make it a lot easier. And this is how we do it. First, we create an array with both of them. And the first one is going to be the secondary. And then the second one will be the main. And actually, before we do that, let me just show you that this worked. So main and secondary. And so now we should see them switched. Oh, okay. Here we need to change, of course, to let, because we are reassigning here to a const in line 24. So let's try that now. And indeed, what was Italian is now vegetarian, and what was vegetarian is now Italian. So this here worked indeed, but let's now take this out so that we can do it using destructuring. So as I was saying, in order to switch the two variables using destructuring, we would first start by creating a new array with the two variables inverted. So first secondary and then main, and then we can simply destruct them. So main and secondary equals the destructuring of this array. And now we're not using let or const here, because we are simply reassigning the values of the two variables. So just like we did here. But now we do not need a temporary variable in the middle. So let's check now. And indeed, the result is the same. But this is a lot easier. And this is a trick here that I actually use all the time. So let me just show here, or actually write here, switching variables. Okay, so that's a pretty cool trick. And another trick with destructuring is that we can have a function return an array, and then we can immediately destruct the result into different variables. And so this basically allows us to return multiple values from a function. And so let's try that and write a function to order food. So here in our restaurant, let's now add a method, and I'm going to call it order. So this will be a function, and it will accept two parameters. One index for the starter menu, so this menu, and then one index for the main menu. And then the person will order basically by giving the index for each of the menus. So something very simple, just to illustrate the point here. So let's say starter index and main index. Okay, and so we will simply now return the content of the arrays based on the given indexes. So return. And so as I said, we're going to return an array. And then we go to this dot starter menu. Okay. And remember how the this keyword here is set, as we learned in the last section. And so now we go to the position of the starter index that we passed into the function. Okay, that makes sense. Then the same with the main menu at the position of the main index that is passed in. All right. So here we are, of course, not doing any destructuring yet, but now is the time where we will do it. So let's call order, or in fact, restaurant.order, and let's use 2 and 0. So we want element number 2 from the starter menu, so the garlic bread, and the number 0 from the main menu, which is pizza. So we're going to receive an array with that, right? Let me just show that to you. And indeed, it is garlic bread and pizza. And so now we can simply destructure that. So this is the destructuring assignment. And so let's say starter and main should equal these two results. So let's log them, starter and main. Oh, and now this was already defined before. So let's just call this one here the main course. And now indeed we get garlic bread and pizza. All right, so this is how we basically receive two return values from a function. All right, so of course we could have done that without destructuring and still return an array from the function, but this is a very handy way of then immediately creating two variables out of one function call. Okay, and now that you understand how destructuring works, let's take it one step further. Because what happens if we have a nested array? So let's say nested. And with nested, we mean one array inside another. So let's say that we now here have another array, 5 and 6. So an array inside an array. And I'm not sure if we did that before, but of course that's perfectly acceptable. So as a small exercise, how can we get this value here and this entire array? Well, we simply define two new variables using the destructuring assignment. Let's call them I and j. And remember that we do not want in the middle. So we just skip it. So simply leave a space and then another comma, and then this one is going to be j equals to the array from which they should be taken. And indeed, we get the number 2 and then the array 5 and 6. Great, but what if we actually wanted all the individual values? Well, then we would essentially have to do destructuring inside of destructuring. So that sounds complicated, but it's not. So let's take out these here, and let's create now 3 variables. So one for this, one for the 5, and one for the 6. So we're going to skip the 4 again. So that's going to be I, then again the whole here, and now here we can destruct this inner array immediately. So we use the destructuring here again, and so now j for the first element and k for the second. So for 5 and 6. And then again, the array from which to take. And then let's take a look. And so this should now give us 2, 5, and 6 as separate variables. And yes. So that's how nested destructuring works. Basically, we need to do destructuring inside of destructuring. Okay, and now to finish, there's just another feature of destructuring that I want to show you. So we can also set default values for the variables when we are extracting them. And that's going to be very useful in the case that we don't know the length of the array. And this can sometimes happen in real-world applications, as you will see later. So if we have an array that is shorter than we might think, then we might try to unpack the array in positions that don't even exist. So let me say here just default values, and here nested destructuring. So learning a lot of stuff here about destructuring. And so let's now say that we have this array, 8 and 9, and then we are trying to destructure it. So just pretend that we actually don't know the array, all right? And so we might try to take 3 elements out of the array using, again, destructuring. So let's call them P, Q, and R. And then let's try to log them all, P, Q, and R. And so now here we get undefined as the third one. So this would basically be the same as trying to read the element at position number 2 of this array. But it only has elements at position 0 and 1. And so therefore we then get undefined. But as I said, we can set default values. So let's simply set them all to 1. And then, or R will become 1. Great. And if we remove this element, then Q will also become 1. Okay? And as I said, this can sometimes be useful, for example, when we get data from an API. And so we're gonna probably use this one and actually everything that we did in this lecture a bit later in the course. So we talked about destructuring arrays, but we can also destructure objects. So let's do that now. And this time, let's actually write the code before the previous lecture. So right here after this restaurant object, so that we don't have to scroll too much. Also, I added this object here to the restaurant object. And so that was already in your starter files, but I didn't have it here yet. Anyway, let's now talk about object destructuring. And so to do that, we use the curly braces to destructure. So to destructure objects, we use the curly braces, because this is also how we create objects, right? Then all we have to do is to provide the variable names that exactly match the property names that we want to retrieve from the object. So the obvious choice here of object to destructure is restaurant. So let's take the name, categories, and opening hours. So again, let's start with const in order to actually define some variable names. And now, as I said, we need to write the exact property names here to now extract variables from this object. Now, since in an object the order of elements does not matter, we don't need to manually skip elements like we did in an array. So we can simply write name, so that's the restaurant name here, and then also remember that in objects the order of the elements does not matter. And so we can also then take now the opening hours, which is kind of the last property, and only then the categories. And then we simply say equal restaurant. So that's exactly the same as with arrays. But now here we use the curly braces and we have to specify the name of the properties. But just like with arrays, this now creates 3 brand new variables. So based on this restaurant object. So let's see. Name, opening hours, and categories. And indeed, here they are. Okay. So that's the fundamentals of destructuring objects. And once again, this is an extremely useful addition to the language, especially when we deal with the result of an API call, which basically means to get data from another web application like weather data or data about movies or something like that. And this data usually comes in the form of objects, basically. And then destructuring is really a lifesaver. It allows us to write a lot less code. So this is really used in modern applications. But now, what if we wanted the variable names to be different from the property names? Well, we can do it like this. Now, of course, we still need to reference the property names like we did before. Otherwise, JavaScript has no way of knowing what we actually want. So let's write name again, but then we can use the colon and specify a new name. Let's say we actually want it to be called restaurant name. And then here, let's say we want the opening hours, but we want the variable to be called just hours. And then once again, we want to take the categories, but we want the variable name to be called tags. And then again, equal to restaurant. And so the variables that we now created are called restaurant name, hours, and tags. So basically this, and this. And VS Code is nice enough to put them in this purple color here too. And so you see that these 3 are actually the exact same name, but we were able to give them new variable names, which again is going to be immensely helpful when dealing with third-party data. And another useful feature for when we are dealing with third-party data like that, so like an object that we get from somewhere else, for example, an API call, as I was just explaining, it can be really useful to have default values for the case that we're trying to read a property that does not exist on the object. So usually then we get an undefined. For example, if we were trying to say restaurant.menu, this would be undefined because there is no property called menu. We have starter menu and main menu, but not just menu. Okay, and so we can set default values just like we can actually in arrays. So let's say that we are trying to destructuring the menu, and so we use equal to set a default value. All right, and then we can do the same with the starter menu, for example, and then we can even combine this syntax here with what we did previously. So let me show you. So let's say that we're trying to retrieve the starter menu. So this one, but we then want to give it another name. So starter menu, and we want to call it just starters. And we also want to give it a default value in case it doesn't exist. So in this case, just an empty array. Now in this case, it actually does exist. So starter menu does exist. And so therefore this default value will not apply, but it should apply to menu. Because as I was just saying, there is no property on the restaurant object called menu. So menu and starters. And so here indeed we get the default value, which is the empty array. And here we get the starter menu. And without this, we would then get undefined, as I was saying. You see? And so this is a nice way of setting a default value. And once again, keep in mind that this is especially helpful when we do not have our data hard-coded like we have it here. So this is just hard-coded data in our application, but in the real world, we usually get the data from somewhere else. And then we might not always know how exactly the data looks like. And so then it's useful to set defaults like this. Next up, we need to talk about mutating variables while destructuring objects. So we did that before with arrays when we were switching variables. Remember that? So let's see. Down here, you see that we mutated these variables that we created before. But with objects, it works a little bit differently. And so let's write that here. Mutating variables. And here let's write default values. So let's say that we already have some variables here. So A and B. And then we have this object, which has a property A of 23, property B of 7, and C of 14, let's say. All right. And now we want to destructure this object. And actually, let's first store it into a variable. That makes it a bit easier to work with it. And so now actually let us destructure this array. Now we cannot say const like A, B, because A and B are already declared up here, right? We can also not do let, because again, that would create new variables and we already have them there. Okay, so here we are missing the object that we are destructuring. But as I was saying, we cannot do this. And so in fact, we want to mutate these variables. So A should become 23 and B should become 7. But now as we save this, watch what happens. And so we get a syntax error. And the reason for that is that when we start a line with a curly brace like this, then JavaScript expects a code block, all right? And since we cannot assign anything to a code block like we did here with the equal sign, then we get this error unexpected token with the equal there. So to solve this here, the trick is to wrap all of this into parentheses. And so that's the thing that I wanted to show you here. Okay, so now if we log A and B, it will work. So you see, now we get 23 and 7. So basically we did override these two initial variables, but in order to do it, we had to wrap this destructuring assignment into parentheses. All right, and now we already know how object destructuring works, and so now we need to talk about nested objects, just like we did with nested arrays. So let's say we wanted to create two variables, open and close. And these should contain the open and close hours for Friday. Okay, so you see that opening hours is an object, and then in that object, we have another object. So this Friday is an object inside an object, which itself is inside the restaurant object. Okay, now the opening hours is already an object here that we have already stored in a variable. So that's the object that we're going to destructure. So nested objects. So again, we're going to start with opening hours, and now we want to retrieve Saturday. So let's start with doing that. So just Saturday for now. Or actually Friday. So I think I said Friday. So let's see. And so indeed, Friday is this object that we get here. But remember that we actually want two variables, one called open and the other one called close. And this is how that works. So we know that this is an object, and now we can further destructure that object using this syntax. So the colon, and then again the exact property name of that inner object. Okay. So that looks confusing, but that's just the syntax that we have to use. So maybe you don't even need to memorize this, but when you need this someday, and you will, then you can just come to this video and see how it works. And so indeed, now we get our numbers 11 and 23. And we could, of course, take this even further and even assign different variables to these, just like we did up here. So with the colon again. So we could call this one just O, and this one just C. So this is taking it to an extreme, but as I said in the beginning, destructuring is really powerful. So there's a lot of stuff we can do with it, and that's why I'm showing you all of it right now. Okay, and now to finish, let me actually show you a really cool practical application of this destructuring. And for that, we're going to go back to our object here. So to our example of this section, and now we will create another method. So many times in JavaScript, we have functions with a lot of parameters. And then it can be hard to know the order of parameters for someone that is using this function. And so instead of defining the parameters manually, we can just pass an object into the function as an argument, and the function will then immediately destructure that object. So let me show you what I mean. And let's say we want an order delivery. So that's a new function. Okay. And so here, let's just for now call this argument object. And then I will log that object to the console here. And now let me call this actually. And I will do it right here so that we can see everything at the same time. So that is restaurant.orderDelivery. And now here comes that object of options. So as I said, we can now specify some options here. Let's say the time of delivery, let's set it to 23:30, which is like 10:30 p.m. Let's also say address Via del Sole 21. And then we also specify the main index and the start index. So a little bit like we did up here in this function, starter index. Okay. Oh, and here we need to also give it some value. Let's just say 2 as well. And so, yeah, here, right at the beginning is that object that we just defined, because here we are simply logging it for now, okay? So what we just did was to call this function here and passing in an object of options. And that's a pretty standard thing actually in JavaScript, especially in third-party libraries. Because now, here in the function arguments, we can actually do destructuring right away. So we can now say starter index, main index, time, and address, which is exactly the 4 property names that we have down here. And of course, usually we would first develop the function and then call it, but I wanted to explain you this way of calling a method with an object so that writing the object here then makes sense. All right, and so now instead of the object, since we did the structuring right here, we now actually have 4 variable names. So we can log them to the console, or actually let's do some nice string here. So let's say order received. And then let's get the food. So based on the starter index, let's just copy that from here. So this .starter menu at the current starter index, and then also the main menu. So let's again copy that, actually all of this from here. And we need the curly braces and this $sign will be delivered to, then the address, and then the time. Okay. And so indeed, we get this complete string based on the data that we passed in this single object. Okay. So that's important to realize. We only passed in one object into this function. Okay. We did not pass 4 arguments. It's really just one argument, one object. Then here in the function, as we receive that object, we do immediately destructuring. And so that's why these names here need to be exactly the names that we have down here in the object. But what's great about this is that here, the properties in the index don't have to match the order in which we do destructuring up here. And so that makes it really easy for the user of this function to specify basically the arguments. All right. So this is great, but we can even use some more knowledge that we gained here, which is these default values. So we can now use this to basically set defaults here on some of these. So let's say that the starter index will be 1 if it cannot be destructured, and that the main index will be 0 and the time will be 20 hours. And so now as we call this method, restaurant.orderDelivery, I can specify the address again. Let's actually copy it from here. And let me also just specify the starter index. Okay, but then the rest will be taken from the default values that we set here for destructuring. All right, and so here as a second string, we get will be delivered to Via del Sole at 20 hours. Okay, so in this object that we passed, we do not have any property for the time, right? And so then as JavaScript did destructuring, it here took the default value of 20. Okay, and the same happened for the main index that we also did define. So it shows 0, and 0 is pizza, and that's why we get pizza here in the output string. All right. So if you ever need to write a function like this, so a really complex one with a lot of parameters that might be then hard to specify, keep this technique in mind. And this becomes even more useful as the amount of parameters increases. Let's now talk about the amazing spread operator. So we can use the spread operator to basically expand an array into all its elements. So basically unpacking all the array elements at 1. So let's say that we have an array. So 7, 8, and 9. And now we want to create a new array based on this array, but with some new elements at the beginning. So how would we do that? Well, with what we already know, we would need to loop over this array, or even worse, do it like manually. For example, like this. Let's call it the bad new array. So if we wanted to add 1 and 2 to the beginning of this array, we would have to write 1, 2, and then each of these elements, right? So that would be R0, R1, and R2. Okay, let's take a look. And now indeed we get a new array with the 3 original elements and then a 1, 2 at the beginning of that array. Okay, and this is actually quite a common operation that we need to do. And so we can now, since ES6, do it in a much better way using the spread operator. So with the spread operator, it's going to work like this. So let's create a new array. So this is the good, let's say, new array. And then again, we use 1, 2, and then we use the spread operator, which is ... to basically expand this array into all of its individual elements. So let's see the result, and then I will explain it a little bit better. So new array, and you see that we get the exact same result here. So what the spread operator does is to basically take all the values out of this R array and then write them individually as if we wrote 7, 8, 9 here manually. All right. So if we wrote it without these 3 dots, then we would have this array, so this R array inside of this one. So just like this. So 1, 2, and then an array of 7, 8, 9. And that's because here we are including this entire array. But with the spread operator, again, it's like taking all the elements out of the array and writing them here manually. And so when we do this, we then get 7, 8, 9 individually here represented in this new array. So what this means is that we can use the spread operator whenever we would otherwise write multiple values separated by commas. And that situation happens whenever we write an array literal like we did up here. So that's the first situation in which it's very useful to expand an array. And the second situation is when we pass arguments into functions. So for example, let's say that we wanted to actually log the individual elements of this new array here. So if we simply logged the array, then it's of course going to look like this. It's just one value, which is the array. It's just one big value. But if we use the spread operator to expand the new array, then see what happens then. So now it logged the individual elements of the array. So this would be the same as writing 1, 2, 7, 8, 9 individually. So once again, whenever we need the elements of an array individually, then we can use the spread operator. And that is useful when we write an array and when we need to pass multiple elements into a function like we did here. All right, so let's see a bit more useful example. So in this example, we will create an array with one more food item in the main menu array. So that main menu is here at restaurant.mainMenu. And so basically we want to create a new menu here. So const new menu. And then let's say that we want the original array plus one new element. So we can do that by simply expanding the array. So that's restaurant.main menu. And then we can add other stuff. So let's say gnocchi, I think, at least that's how I think it's spelled or pronounced in Italian. And so let's have a look at our new menu. And indeed, it has the 3 original elements plus the gnocchi. And keep in mind that here we are indeed creating a completely new array. All right. We are, of course, not manipulating the restaurant.main menu array. So we are building a new array from scratch. And you can see that here by these square brackets. So this brackets syntax here is simply the way in which we have always been writing new arrays. And so here, again, we are writing a new array, but simply based on expanding this array and then adding another element to it. Okay. Now, you might have noticed that the spread operator is actually a bit similar to destructuring, because it also helps us get elements out of arrays, right? Now, the big difference is that the spread operator takes all the elements from the array, and it also doesn't create new variables. And as a consequence, we can only use it in places where we would otherwise write values separated by commas. And in case you're taking notes, probably what I just said would be very helpful to have as a note. Next, let's learn about 2 important use cases of the spread operator, which is to create shallow copies of arrays and to merge 2 arrays together. So let's say copy array. And so let's simply create a copy of the main menu. So main menu copy. And so let's write a new array. And into that new array, we will put all the elements that are currently in the main menu. So at restaurant.main menu, and that's it. So here we just created a shallow copy of this array. So that's a little bit similar to object.assign that we used in the previous section. Okay, but here this syntax is actually a lot easier to use. Now to join 2 arrays together, so join 2 arrays or more, of course, we can use the same technique. And so maybe at this point you can already guess how that would work. And so you can do this actually as a challenge. So pause the video right now and create this variable menu, which will be an array which contains the whole menu. So both the main menu and the starter menu. So take a minute and try it on your own here. All right, so hopefully you managed to do that. And so the secret here, again, is to use the spread operator. So restaurant, and let's start with the starter menu. So that's going to be our first couple of elements in this new array. And then, of course, we can use the spread operator again. And then this time expand the main menu. Dot main menu. And so now we end up with an array containing all the food items that are both in the starter and the main menu. And again, because here with this spread operator, we took all the elements out of the starter menu and basically wrote them here into this new array, and then the same with the main menu. All right, so I told you that the spread operator works on arrays, but that's not entirely true, because actually the spread operator works on all so-called iterables. Now, what is an iterable? Well, there are different iterables in JavaScript, and we will talk about all of them by the end of the course. But for now, just know that iterables are things like all arrays, strings, maps, or sets, but not objects. So basically, most of the built-in data structures in JavaScript are now iterables, but except objects. So let me actually write that here for you. Iterables are arrays, strings, maps, and sets, but not objects. Now, anyway, since strings are also iterables, that means that we can use the spread operator on a string as well. So let me quickly show that to you. So let's just create a quick string here, Jonas. And then I want to create an array which contains all the individual letters and plus some other elements. So let's call this one letters. And then we create a new array and expand the string here as well. Then here I want an empty string, and then here I want an S. And now let's log it to the console, and then it will make a little bit more sense. All right. And so indeed, here we get this array where each letter of the original string is now an individual element. So just like we expanded, so we unpacked an array, we now did the same thing with a string. Now just keep in mind that we can still only use the spread operator when building an array or when we pass values into a function. So for example, we can also do this. So expand the string here, and so then it is the same thing as writing this. So J, O, and so on and so forth, right? So indeed, here now we get all the individual elements. All right. So for example, what we can do is to use this to build a string using a template literal. So here, this is not going to work. And that's because this is not a place that expects multiple values separated by a comma. So you see unexpected token. All right. So again, multiple values separated by a comma are usually only expected when we pass arguments into a function or when we build a new array. So take note of that, because that is important to understand about the spread operator. Okay, but now enough with building arrays. Let's now actually write our own function that accepts multiple arguments and then use the spread operator to actually pass those arguments. And so that's going to be a very real life example right there. So let's add here another method now. And so let's say that we want a method to order just pasta, okay? And the pasta always needs to have exactly 3 ingredients. So let's say order pasta, and it's going to be a function. And so now here we need 3 ingredients. So let's just call them inc1, inc2, and inc3. And then just log them to the console or some string. Here is your delicious pasta with, so inc1, inc2, and inc3. So up here we have an error. So this should be number 3. And then let's now call this function. So order pasta. Now what I want to do here is to actually get these ingredients from a prompt window. So remember the prompt function that we can use. And so let's create an array called ingredients. Ingredients. And each element here will be defined by a prompt window. So this here now has nothing to do with the spread operator. It's just a way so that we can actually input the data ourselves. So let's say, and here we need to escape this. So let's make pasta. Ingredient 1. And I think I didn't show you this escaping here before. So here, when we simply write this single quote here to write let's, JavaScript thinks that we are finishing this string here. Okay, and so we could use the double quotes out here, or we can escape using the backslash. Okay, now when we save this, I think that Prettier will actually get rid of this here. but it's still important to know that escaping exists. So basically this masks this single quote here so that it does not finish the string at this point. So let's save it. And so you see that now the prettier extension actually replaced the single quote with the double quote. And so here we see our prompt already, but let's create two more. So let's say ingredient 2 now, and then another one. So again, here we are simply building an array of the 3 ingredients. Okay, and then we can log it to the console. So just to see A, B, and C. And so indeed, we now get this array ingredients with A, B, and C, which are the 3 strings that we just wrote there. And now, how should we actually call the order pasta function? So restaurant.order pasta. And in the old way, we would now write ingredients 0, ingredients 1, and ingredients 2, right? But since we learned about the spread operator in this lecture, we can now do a lot better. And so instead, we do this. Restaurant.order pasta. And now all we need to do is to expand the elements of the ingredient array. And that will then basically write the 3 elements of the array here separated by commas. So this and this should yield the exact same result. And so let's now test it out with some real data. So let's see, mushrooms, asparagus, and cheese. And so indeed we get now twice. Here is your delicious pasta with mushrooms, asparagus, and cheese. And what do you think is the better solution? This one or this one? And especially considering that an array could of course be a lot longer than just 3 elements. So indeed, always go with this more modern ES6 syntax here. It's an amazing addition to the language. And now just to finish this lecture here, since ES 2018, the spread operator actually also works on objects, even though objects are not iterables. So let's write that here. And here let's just write a real world example. And so let's now experiment with this. The first example here was to create a new array based on one initial array, right? And so let's now also create a new restaurant object with all the data from the original one plus some additional data. And so this is actually an amazing way of doing this because it's so much easier than with old JavaScript. So let's call this one new restaurant. And then we can simply spread the old restaurant, and this will then basically copy all the properties of the restaurant into this new object. And then we can add anything that we want. Founder, for example, let's say Giuseppe or Giuseppe, I don't really know how to say it. And of course here the order does not matter as always. So this spread here doesn't even have to be the first one. So let's say we also want the founding year, let's say 1998. Okay, and so with this we created a brand new object. Now we need to get rid of these 3 prompts there because otherwise it's gonna drive us crazy. So let's just take this out and simply log here the new restaurant to the console. And so indeed we get our original object basically plus the founder and plus founded in. Great. And finally, since we were able to do shallow copies of arrays using the spread operator, we can do the same with objects. So instead of using object.assign as we did it in the previous lecture. So let's do that. Restaurant copy. And so all we need to do is an empty object, and then in there expand all the elements of the original object, so the restaurant in this case. And so now if we attempt to change something on the copy dot name, let's call it now Ristorante Roma. And if you're Italian, you're not gonna like how that sounds. But anyway, now as we take a look at both of them, so the name of the copy and the original, now you will see that they are different. So the copy has the name of Ristorante Roma, and the old one has Classico Italiano, which means that indeed we did make a copy of the original restaurant, because otherwise, as we learned by the end of the previous section, changing one object would then also change the other one, right? Cool. So another long lecture here, but we're making really great progress. And of course, we will use all this in real projects later down the road. But again, I chose to teach you these concepts in a separate way and not inside a big project, because this allows me to show you a lot more different examples, and it also makes the material more referenceable for you in the future. And so that's going to be helpful when you're trying to find what you're looking for after taking this course. Moving on, let's now talk about the REST pattern and also REST parameters. And the REST pattern looks exactly like the spread operator. So it has the same syntax with the 3 dots, but it actually does the opposite of the spread operator. Now that doesn't seem to make much sense, right? But let me explain. So remember that we used the spread operator to build new arrays or to pass multiple values into a function. So those are the 2 use cases of the spread operator. And in both cases, we use the spread operator to expand an array into individual elements. Now the REST pattern uses the exact same syntax, however, to collect multiple elements and condense them into an array. So that's really the opposite of spread. The spread operator is to unpack an array, while REST is to pack elements into an array. And since that sounds really confusing, let's write some code. And let's start by exploring the use case of building arrays. So just to recap, in the last lecture, we used the spread array like this. So we wanted to create a new array based on an existing array. And so we used the spread operator to expand that. So here we are still using the spread syntax. And we know that this is the spread syntax because we are using it on the right-hand side of the assignment operator, so of the equal sign. So let me actually write that here. Spread, because on the right side of the assignment operator. However, we can also use it on the left-hand side of the assignment operator together with destructuring. So now we're mixing kind of everything together here, but bear with me here. So let's say that we are destructuring this array. So let me first write the array here, 2, 3, 4, and 5. And so let's say I want to take the first element, store it in variable A, the second element to store in variable B, and now I can here use the REST pattern. So the same syntax, and now let's call this others. And so here it is the REST syntax because it's on the left-hand side of the assignment operator. First write that and then see the result, because on left side of the equal sign. And so now let's log A, B, and the others, whatever that's gonna be. And so 1, 2, and then basically the rest of the elements that we did not select into the A and the B variables. So what is happening here? Well, just like before, the first and the second elements become this first and second variables. But then here comes the rest pattern. And so it's called rest because it will take the rest of the elements, so the remaining elements of the array, and then put them into a new array. And in this case, we call this array others. So as I said in the beginning, the rest pattern basically collects the elements that are unused in the destructuring assignment. So let's see another example here. And this will show you that we can actually use the 3 dots on both sides of the assignment operator. So let's say that we have this array, which will be the entire menu. And so we already know how to build that using the spread operator. So we go to restaurant.mainMenu. So that's dot. So we take all the elements out of that array and put it into a new array. And then into this new array, we also put the starter menu. Okay, so this is going to be an array, a big array with all the entire menu. But now we can actually also use the rest pattern here. And so again, we do that here on the left-hand side while we are doing destructuring. So let's take a look here at the main menu. So let's say that we want to take the pizza and the risotto. Okay, so that's the first and the third. So let's create a variable called pizza. Then we can skip one variable, remember, so leaving a hole there in the destructuring assignment. Then let's call one variable risotto, and then simply put all the other food, well, into an array called other food. And now let's simply log everything here to the console. All right, so we get indeed the string pizza, the string risotto, and then all the rest of the elements that we didn't select previously into their own variables. And note here that the rest syntax collects all the array elements after the last variable. So in this case here, risotto. So it does not include any skipped elements. So it's really just the rest of the elements. And yeah, again, as I said, it does not include any skipped elements. And so for that reason, the rest pattern always must be the last in the destructuring assignment, because otherwise, how will JavaScript know until when it should collect the rest of the array, right? So for example, we could not do this. So the error message is actually very explicit. So the rest element must be the last element. All right. And also for the same reason, there can only ever be one rest in any destructuring assignment. Okay. And now let's do the same in objects, because it also works indeed in objects. So the difference then, of course, is that the remaining elements will be collected into a new object and not into a new array. So let's now work here with our opening hours. And let's say that we want to select only Saturday here. And then the rest should go into a new object, which are the weekdays. So Saturday is weekend, and Friday and Thursday are the weekdays. And so basically we want to create an object only with these two. So only for the weekdays. And now that is easy to do. All we need to do is to basically take out Saturday into its own variable, and then we simply collect the rest into a new object. And this we can call weekdays. Okay. And then here, of course, the object that we are destructuring. Dot opening hours. And now let's take a look at our weekdays here. And indeed, it is exactly what we were expecting. It is an object only containing Friday and Thursday. And again, that's because we already took Saturday into its own variable before. And so this then collected the rest of the properties into its own new object. Great. So now we know how the REST pattern works to collect elements in a destructuring assignment. And actually, let's write that here. So this whole first part is for destructuring. And then the second part will be about functions, basically. So remember that also for the spread operator, the second use case was to pass multiple arguments into a function all at the same time. So that's exactly what we did here in our real example with this ingredients array, right? So we had an array, and then we expanded all of these elements of the array to basically pass these elements then as individual arguments of the function. And so now, as you can guess, the REST operator can basically do the opposite. And so let's now write an example function for that. So I'm going to call it add. And so in a real adding function, we want to take an arbitrary amount of arguments and simply add all of them together, right? So function, and for now, let's just leave it like this. And so let me illustrate how we want to call this function actually. So we want to be able to do, for example, this 2 and 3. It should give us 5. But then we also might want to be able to do this 5 and 3 and 7 and 2, for example. So again, any arbitrary amount of arguments should work for this function. So something like this, for example. But of course, we're not going to specify like 7 arguments here, right? So how can we do that? Well, we will use the REST pattern. And in this case, it is actually called REST parameters. So let's use the REST syntax, and then let's call this argument numbers. And here, let's then log these numbers to the console. So this function is going to be called 3 times. And so we are expecting 3 results here. And what we see here is 3 arrays with all the arguments that we passed into the functions. But they are indeed arrays. And so now, once again, as I said in the beginning, the REST syntax is taking multiple numbers or multiple values and then packs them all into one array. So once more, it is doing the opposite of the spread operator. So with the spread operator, we expand. With the REST syntax, we compress. So here it's called REST arguments. Okay? And now we can write some simple logic here to actually add all the numbers together. I believe we already did that. So here is our sum variable that's going to be accumulating. Then let's write a simple for loop. And you could also do this here as a challenge if you wanted. But anyway, I will just do it right away. So we know that numbers is an array, and so we can take the length of that array and run this loop as long as the counter is below the length of the array. And in each iteration, we simply add the current number to the current sum value, basically. So I'm writing this really fast because we already did this before. All right. And so this should be nothing new at this point. And now to finish, we can log this sum to the console to get some results. And indeed, this here is now 5. And so this is at this point a working function which can accept any number of parameters. And hopefully you're not confused yet by this. And now I want to take it even to the next level. So let's create yet another array. Let's just call it X because it's not important. And I will put in numbers 23 and let's say 5 and 7. So now if we wanted to take these values here and call the add function with these 3 values, how would we do that? Well, simple enough. we simply use the spread operator. And that's it. And so this is exactly what we learned in the previous lecture. So we're taking all the numbers of the array and spreading them here. And so this would be the same as writing manually 23, 5, and 7. And so this is a good example of showing you how spread is the opposite of rest. Because after these numbers being spread here, they will then enter this add function here, and then they will immediately be collected into this numbers array by the rest parameters. Okay? So here we unpack the values, and here we pack them back again into an array. And you could actually be wondering why we are not simply writing an add function which takes an array as an argument, and then we don't need all of this. Well, it's way better to do it like this, because then the function can accept both an array, basically by doing this, and simply all the single values, like this. And also it feels a little bit more natural to simply pass as many arguments as we want to add together into the function. So without having to deal with arrays if we don't want to. And so this rest parameters is something that you will see all the time in modern JavaScript code bases. Okay, and now just to finish this, let's actually use rest parameters in our restaurant example here, also to see some edge cases. So let's add yet another method here. And this time the method is going to be about ordering pizza. So order pizza. And now pizzas need to have at least one ingredient, but the other ingredients are optional. And for this, rest parameters are perfect. So let's say main ingredient, and then the other ingredients. And so now this is going to work a little bit like destructuring again, where then this here basically will collect all of the rest of the arguments into an array. So let's see that. So main ingredient, and let's log the other ingredients. Okay, and so now let's order pizza. So restaurant.order pizza. And now here we specify our ingredients. So let's say mushrooms, onion, olives, and spinach. So nice vegetarian pizza right here. And so you see, we can specify as many arguments as we wanted. Let's save this. And you see down here immediately that we get mushrooms, which is this first ingredient here. And then we get an array of all the remaining ingredients that we passed in. And so this, of course, is the result of the rest arguments. So again, the first argument was stored into this main argument here. And then all the remaining arguments that were passed in were simply stored into this array by the rest parameter syntax. Okay. And of course, we could also simply define just one. So let's order now a pizza with only mushrooms. Then the remaining arguments here will simply be put in an empty array because, of course, there are none. And so there is nothing to collect into the array, but we still get an empty array that we can work with if we want. So in that function, we could now create some logic, like to create a string based on all of these ingredients, but I'm not going to go into that right now. But if you want to have some fun, then feel, of course, free to do that by yourself. Anyway, the takeaway from this example is that, once again, the rest parameters serves to collect all of the remaining, basically unused parameters that were not used in this parameter. All right, so let's recap after yet another quite long lecture here. So the spread and the REST syntax both look exactly the same, but they work in opposite ways depending on where they are used. So the spread operator is used where we would otherwise write values separated by a comma. On the other hand, the REST pattern is basically used where we would otherwise write variable names separated by commas. So again, the REST pattern can be used where we would write variable names separated by commas and not values separated by commas. So it's a subtle distinction, but this is how you know when and where to use spread and REST. Let's go back to two logical operators that we already used before, but we didn't use their full potential yet. And I'm talking about the AND operator and the OR operator, and how we can use them for something called short circuiting. So up until this point, we have used logical operators only to combine Boolean values. But the truth is that we can do a lot more with the AND and OR operators. So let's start with the OR operator here. And so let me log 3 or Jonas. So that's something that we didn't do before, which is to use basically non-Boolean values here as the operands. Okay, so let's see what the result of this is going to be. And for some reason I have to reload here. And you see that the result is 3. And so that means that the result of the OR operator doesn't always have to be a Boolean. And so that's something that I didn't show you before. So there are 3 properties that I didn't tell you before about logical operators. So first, they can use any data type. They can return any data type, and they do something called short circuiting, or as we also call it, short circuit evaluation. So in fact, here we used 2 values that are not Booleans, okay, and it then returned a value that was not a Boolean. And now about short circuiting. In the case of the OR operator, short circuiting means that if the first value is a truthy value, it will immediately return that first value. So that's exactly what we see here with the 3, which is a truthy value. So again, if the first operand is truthy here in the OR operator, then the other operand will not even be evaluated. So JavaScript will not even take a look at it. And so that's what we mean with short circuiting. And now let's do some more. Let's use the empty string or Jonas now. Then let's say true or 0. And then let's say undefined or null. And now, before taking a look at the result, try to take a guess of what the result of these 3 operations here will be. So did you do that? So let's see. So the first result of this one here is Jonas. And so that's because this here is a falsy value. And so then the second operand will actually also be evaluated, and that's Jonas, and it will then be returned. And so here we see again that the result of the OR operator doesn't have to be a Boolean. It will simply return the truthy value here. Next up, we have true or 0. And so this first value here is truthy, and in fact, it's even true. And so therefore, that will simply be the result of the operator. And so that's what we see here. And then here we have undefined or null. And as you already know, undefined is a falsy value, and so we then go to the second operand, so there is no short circuiting, and so that's then the one that's going to be returned. So here we see null, and that happens even though null is also a falsy value. And let's actually now generalize this to more operators, so I can give you basically the general rule of how this operator works, no matter with how many values. So let's say undefined or 0 or empty string or hello or 23 or null. So what do you think that the result of this one will be? And it is hello. And that's essentially because hello here is the first truthy value in this chain of OR operations. So we start with this one. So undefined is falsy. And so then we go to the next one, which is also falsy. And so then to the next one, which is also falsy. And then we get hello. And hello is truthy. And so therefore it will short circuit the entire evaluation and it will be the returned value. Okay? And if we think about this, then it actually makes sense. Because remember, in the OR operation, the result is true if at least one operand is true, right? So if the first operand is already true, for example, as it happens here, then JavaScript doesn't even have to look at the other values, because the result of the expression will already be true anyway. And so it will short circuit and then simply return that first result. And now let's see a more practical application of this. So let's say that there might be a property on the restaurant object with the number of guests. So something like this, restaurant.num guests. But again, we don't know if it exists. However, we want to basically define a variable based on this number of guests, and we want to set a default value if this doesn't exist. So basically, what we want to do is this. So guests, I'm going to call it 1 here. And so what we want to do is this. We want to check if it exists, and then the result should be actually restaurant.numGuests. But if it doesn't exist, then we want to set a default value of 10. So let's log guests1 to the console. And so you see that now it is 10. And so that's because restaurant.numGuests doesn't exist. So this is undefined. And so therefore 10 will be the result of this ternary operator. Okay, but now if we do set the property like this, for example, to 23, then guests1 is going to be 23. So, but instead of doing this, we can take advantage of short-circuiting and the OR operator. So let's again write restaurant.numGuests and then simply OR 10. So let's analyze why this works. And first actually store this into a variable. So guests2 equals this, and then console log guests2. So let's take a look at why this works, and starting again with disabling this. And so right now, restaurant.numberOfGuests is undefined. So it's a falsy value, and as we already know, then the second value here will be the result of the OR operator. And so that's basically our default value of 10. So let's take a look. And indeed, we get 10 here. But now if we put it back on, then restaurant.numberOfGuests is now 23, which is a truthy value. And therefore the OR operator short circuits and it will become the return value, or let's say the result of the operation. And so now indeed we get 23. And so this is a way easier method of setting default values than having to deal with this ternary operator, or even worse, an if-else statement. Okay, so that is short-circuiting with the AND operator, but we can also do the same with the OR operator, but the AND operator also has short-circuiting. So let's take a look. And we'll start by log something to the console here, like a string to separate, so that we don't get confused by the results in the console then. Oh, but before we talk about the AND operator here, there's actually one more thing that I need to tell you here, which is that both of these solutions here, this and this, will not work when the number of guests is 0. So let's see what happens. And so now they're both 10. And that's not the result that we want, but given what we already know, it makes sense. Because this is now 0, so it's a falsy value, and therefore the second one here will be the result of the operation, and therefore assigned to guests 2. However, 0 is the real number of guests, and so that's the value that we actually would guests 2 to have. But instead, it set the default value of 10. So that's obviously not what we want, and we will explore a great solution to this problem actually in the next lecture. But now, let's talk about the AND operator. And basically, when it comes to short-circuit evaluation, the AND operator works in the exact opposite way of the OR operator. So let's see, 0 and Jonas. And now the result of this is 0. And so what this means is that the AND operator short circuits when the first value is falsy, and then immediately returns that falsy value without even evaluating the second operand. So again, that's exactly the opposite of what happens with the OR operator, which short circuits when the first operator is true. So let's now set it to a true value here, or actually a truthy value, and then in this case, Jonas is actually returned. So when it is truthy, it means that the evaluation continues, and then simply the last value is returned. And once again, this makes sense if we think about it. So the AND operator is only true if all the operands are true. And so if the first one here is false, then it means that the entire result of the AND operation will already be false anyway. And so there's no need to even look at any of the other operands. So I think that's a good way to memorize how both of them work. Anyway, let's again generalize this to multiple operands here. And 23, and null, and Jonas. And so what do you think this time the result will be? Well, let's see. And it is indeed null. And to understand why, let's apply the same logic as before. So this is a truthy value, and therefore the evaluation continues. 23 is also truthy, but then null is a falsy value, and therefore the evaluation no longer needs to continue, because at this point the whole result of the AND operation is going to be false anyway. And then as a result, this is then simply the value that's going to be returned, and it short circuits the rest of the evaluation. So it will not even take a look at Jonas here. All right, and so now let's see another practical example. So let's say if restaurant.order pizza. So basically we're checking if this method exists, and then if it does exist, we want to call it. So restaurant.order pizza, let's say with mushrooms and spinach. So many times we can use the AND operator to actually avoid an if statement like this one, where all we want to do is to check if a certain property or value actually exists. Okay, so in this case here, what we're doing is to basically pretending that we don't know if order pizza exists. And so we first check if it exists, and only then we execute it. And so this now gives us mushrooms and spinach, but with the knowledge that we gained about the AND operator, we can do this in a simpler way. So we can say restaurant.order pizza and then basically if restaurant.order pizza does not exist, so it's undefined, it will then short circuit the evaluation and nothing else will happen. And so that's essentially exactly the same as this if block here is doing. All right. But if it does exist, so if it's a truthy value, then the second part here will be evaluated. And so here in this second operand, we can then call the function. Okay. And it's perfectly fine to use this operand, this second operand here, to call a function. We can put anything here. It doesn't just have to be a single value. Now, I'm not saying that you should go ahead and replace all your if statements with the AND or the OR operators. So please definitely don't do that, because it's going to make your code very hard to read in the future. But anyway, let's now summarize. So the OR operator will return the first truthy value of all the operands, or simply the last value if all of them are falsy. So that's what happened here, right? On the other hand, the AND operator will return the first falsy value or the last value if all of them are truthy. And as for practical applications, we can use the OR operator to set default values, and we can use the AND operator to execute code in the second operand if the first one is true. So play around some more with this maybe, and then let's just move on to the next video where we will solve this problem that we had here with this OR operator and this 0. Let's now learn about the new operator with the funny name of nullish coalescing operator. So in the last video, we used the OR operator to set a default value in case that the first value was a falsy value. So let me bring back that code here actually. So this one, but we're only interested in the OR operator here. So let's call this one simply guest. And so let's again remember what happens here, which is when we set numGuests to 0, then JavaScript will still take this default value here and assign it to guests, because 0 is a falsy value now, and so therefore we go to the second operand. However, fortunately for us, there is a very good solution to this. And that's the new operator with the very weird name of nullish coalescing operator. It's an operator that was introduced in ES 2020, and it works like this. So guests, let's call this one correct now. And so it works almost the same way as the OR operator. Really almost the same, but it will fix our error here. So let's see that it does, and then I will explain you why that is. All right, and now indeed we get 0. So we get the real value that is actually here. And now if we take it off, only then we get 10, which is the default value that we want. So why does this work? Well, it is because the nullish coalescing operator works with the idea or with the concept of nullish values instead of falsy values. And nullish values are null and undefined. That's it. It does not include a 0 or the empty string. So basically, for the nullish coalescing operator, it is as if the 0 and the empty string were not falsy values and were instead truthy values as well. But again, this operator does work with the principle of nullish values. And so only nullish values will short circuit the evaluation here. Okay, so only if this was null or undefined, only then the second operand here would be executed and returned. And so right now that's the case, as number of guests does not exist. So we commented it out here. And so now it is undefined. And so only then the evaluation continues. But again, as we put it back, it now is 0. And 0 is not a nullish value. And therefore the evaluation here is short-circuited, and immediately this first non-nullish value is returned. All right, and that's actually all for now about this nullish coalescing operator. It's a really great and really useful operator, even though right now it might not seem that useful. But as we go through the project, you will see that it really is. Now, even more modern than the nullish coalescing operator that we just talked about are three new so-called logical assignment operators that were introduced in ES 2021. So let's see how they work. And in order to do that in an effective way, let's quickly start by creating two new restaurant objects. So I'm going to call them Restaurant 1 and Restaurant 2, and they are extremely simple. They just have a name, and then this one has a property, number of guests, and let's set it to 20 here. And then there will also be a Restaurant 2. And in fact, let's just duplicate this one here. Restaurant 2. Call this one La Piazza. And this one actually doesn't have the number of guests property, but it has an owner. So Giovanni Rossi or whatever. Okay, and the first thing that we want to do now is to set a default number of guests for all the restaurant objects that do not have that property. So in this case, it is just this restaurant here, but let's pretend that we got them, so that we got these restaurants from some kind of API, and now we want to apply something to all of them. So in this case, basically adding the number of guests property to the objects that do not have them. And let's start by using the tool that we already know about to do this. And so that is the OR operator. So we already know how we can do this using the OR operator, right? So let's say rest2 dot number of guests should be equal to rest1 dot num guests or 10. So let's quickly remember that this works because of short circuiting. So in the OR operator, if the first value is truthy, so this one here, then that first value will immediately be returned and the second value will not even be evaluated. So that's this one here. And so by doing this, and here actually should be num guests. So again, by doing this, here we are returning the number of guests if it does exist, so if it's not falsy, and otherwise the 10 is going to be returned. Okay, and in fact, let's duplicate this line here. But first I should fix it, because of course the number of guests in Restaurant 2 should be set based on the number of guests that are in Restaurant 2 or not. But anyway, I'm duplicating this now, and then doing it for both restaurants here, so that we can see the result here for both objects. So let's see, and here we go. So the second one here didn't have a number of guests, and so now num guests is 10. And again, that is because of short circuiting. So this here returned undefined, and so then the second one got returned. While here, in this one, this value was 20, and so it is this 20 that immediately got returned. So nothing new up until this point, but now let me introduce the very first logical assignment operator, which is the OR assignment operator. So with that operator, we will be able to write the same thing basically in a more concise way. So rest1 dot num guests. And now instead of repeating the same thing again, like I did here, I can simply write OR equal, and then 10. And that's it. So this here is exactly the same as this one, but in a more concise way. Okay, let's do the same for Restaurant 2. And if we comment out these two now, then as you see, the result is exactly the same. Great. So let's write here the OR assignment operator. And basically, this operator assigns a value to a variable if that variable is currently falsy. So again, exactly what's happening here. Because this variable is currently falsy, and so it will be assigned the value of 10. Great. So that works beautifully, except in one situation that actually we already encountered before in the previous lecture. So let's actually duplicate this here, comment out this one, and now setting the number of guests to 0, which is a perfectly reasonable number, right? But look what happens if I then run this code again. As we can see here, it is back to being 10, even though we set it to 0 here. So can you guess why that is happening based on what we learned in the last lecture? Well, 0 is actually a falsy value. And so this OR assignment operator is actually working just fine. So this here right now is falsy, and so therefore it will then be assigned this value of 10, which is exactly what this operator does. So again, the logical OR assignment operator will assign a value to a variable if that exact variable is falsy right now. However, fortunately, we have a good way of solving this. So let's copy all of this, put it here, comment out these two because they don't really work. And so here we actually do also have the logical nullish assignment operator. Sounds a bit complicated, but really all it is to change the OR for the nullish coalescing operator. So let's actually write that also here. Nullish assignment operator. So if I save it now, then it is back to 0 here. And that is exactly the correct result here. Let's just remember here that nullish basically means null or undefined. And right here in restaurant 2, the number of guests is undefined. And so therefore, then the 10 will be assigned to that variable. And so in a nutshell, the nullish assignment operator will assign a value to a variable if that exact variable is currently nullish. So again, that is the case in restaurant number 2. Okay, and as you can probably guess, we do also have the logical AND assignment operator. And to learn about that one, let's say that we want to anonymize the names of the restaurant owners. So when there currently is an owner, like here in this object, we want to basically replace this string here with the string anonymous. So how could we do that? Again, using the tools that we already know. Well, let's say rest2.owner, and now let's use for now just an AND operator. So we can say rest2.owner, and then let's write it like this, anonymous. Okay, let's see for now if this worked, and indeed it did. So it replaced the string that we had here before with this anonymous. And so let's remember why this works. Well, once again, it is because of short circuiting. And in the particular case of the AND operator, it short circuits when the first value is falsy, and then immediately returns that falsy value. So in this case, that's not what's happening. So this is truthy right now, and so therefore the second value will then actually be evaluated and returned. So if we duplicated this, like this, then you see that it's now actually being set to undefined, because, well, the restaurant1.owner does not exist. So that property is not here, and so this value is undefined. And since the AND operator short circuits when the first value is falsy, well, then that is the value that is immediately returned. So again, we already learned about that a little bit earlier in the section, and so that's why I'm not going really deep into the details here once again. What I will go into detail is that we can now replace once again this duplicate variable here. So basically replacing it with the AND assignment operator. So for doing that, I can write rest1 and equal, and then here let's just copy this string. All right, and copying it for restaurant2. And I can then comment these two out, and just for the sake of completeness, let's also write it here. Oh, and we get an error here, and that's of course because I forgot the number of guests. And actually it is .owner, of course. So .owner, let's see, and there we go. So the owner has been replaced with anonymous in this case, and here in the case of the first restaurant, the result is even better now than what we had before, because with this code here, we actually had the owner then set to undefined, which was not really what we wanted. Now it is simply not here. And so basically what the logical AND assignment operator does is to assign a value to a variable if it is currently truthy. All right. So clearly this here was falsy because it didn't exist. And so then nothing happened. So the object stayed exactly the same. Then here, this here was indeed truthy. So it was Giovanni before. And so it was replaced now with this other string. And so again, if you ever need to assign a value to a variable that is already defined, so that has a value that is currently truthy, then you can use this AND assignment operator. It's now time for a break from learning so that we can now actually apply everything we learned in this section so far to our first coding challenge. And in this one, we're going to start building a football betting application. And for my American friends, that is called soccer. So let's say that we get some data about a particular football game from a web service. And so this is what that data will look like. So an object with this information about the game, so the date, who scored, the score, an array of 2 arrays with all the players. And you can get this data for yourself either from the challenge PDF file that is at the beginning of the course, or from the final code of this section that is available in the GitHub code repository that you downloaded for this course. Okay, so in this challenge, we are going to work with that data. And so here are your 7 tasks. And trust me, most of them take only 1 minute to complete. Anyway, create one player array for each of the teams and call them players 1 and players 2. In each of the arrays, we assume that the first player in the array is the goalkeeper and the other 10 players are the field players. So for team number 1, which is Bayern Munich, create a variable called GK for the goalkeeper and then an array called field players with all the remaining 10 players. Next up, create an array called all players, which is going to contain all the players of both of the teams. Okay, next up, it says that Bayern Munich used 3 substitute players. So that's team 1. And so I want you to create a new array, this one here, containing all the original players plus Thiago, Coutinho, and Perisic. Next up, take the game.odds object and then create one variable for each of the odds and call them team 1, draw, and team 2. All right, next up, write this function print goals, which should receive an arbitrary number of player names, and so not an array. And then the function prints each of the players to the console and also a string with the number of goals that were scored in total. So that were scored, let's say here, in total. So for example here, it would be 4 goals because we have 4 players. Okay, so for this number 6, use the players Davis, Müller, Lewandowski, and Kimmich. Okay, So first call the function with these 4, and then after that also call the function with the players that are in game.scored. Okay, and so that's the players here that I just showed you, these 4. Finally, we assume that the team with the lower odd is more likely to win. And so now your task is to print to the console which team is actually more likely to win, but without using an if-else statement or the ternary operator. So this might seem like a lot of work, but it's really not that hard, I believe. So please try to do at least some of them, and even if you're not able to maybe finish one of these last 2, it's as always good that you try at least. So take 15 minutes or half an hour, and then I see you back here. All right, hopefully you managed to finish some of these tasks, or even better, all of them. And so now let me show you my solution here. So first off, creating the 2 player 1 and 2 arrays. And so we will do that using destructuring, and we're gonna destructure this players array. Okay, so this is one big array which contains 2 arrays in there. And so we can create one variable for each of these by simply destructuring the original array. So players 1 and players 2 is the result of destructuring game.players. Okay, let's take a look. Players 1 and players 2. And indeed, these are exactly the 2 arrays that before were together in game.players. And now they are these 2 separate arrays. Okay, next up, we should create one variable goalkeeper and then one array with all the remaining players. And whenever you hear remaining, you can think of the rest syntax, right? And so again, we will use destructuring, and we will do it based on the players 1 array. So the team of Bayern Munich. And so from there, we take the first value and store it into the goalkeeper variable. And then the next variable should be called, remember, field players. And it should contain all the remaining values that haven't been taken from the array yet. And so we do that using the rest syntax. So let's check again, goalkeeper and field players. And indeed, that worked beautifully. Next up, our task is to create one array with all the players. So all players. And so simple enough, we can use the spread operator to extend both of the player arrays. So players 1, and so that's the first 11 players. And then we also put all the other 11 players of Borussia Dortmund here as well. Okay. And indeed, we get one single array with 22 elements, so with all of the players in there. So I see that with this, you're starting to see how useful these very simple to use operators are, and that without them, we would have so much more work to do. Anyway, in this exercise, we're going to create a new array, which will contain players 1 plus 3 other players. So that's players 1 final. And so let's just do what I just said. So we take all the players of players 1. So we are unpacking that array basically into this new array. And then we add the 3 new ones. Thiago, Coutinho, and Perisic. And this one, we don't even need to take a look at the console. We can be sure that it's correct. Next up, we want to create 3 variables based on this odds object here. So team 1, then this one here should be called draw, and then team 2. Okay, and so let's actually do nested destructuring here. And so basically do it like this. So we're going to destruct just the game variable. So to make it a little bit more even of a challenge. So we could do game.odds here already, but let's just do it like this. So we take game, and from there we take the odds property. And so if we did just this, then this would now create one variable called odds with the entire object in there. But that's not what we want. And so we can further destructure this result. And so remember, we used the colon here again. And to me, this is maybe the most confusing part of this structuring. But, well, that's just how it works. All right. And so now basically we are inside of the odds object. And so now we can just take team1, x, and team2 out. So team1, x, and team2. But now remember that instead of x, we actually wanted to call it draw. And so we use again a colon and then give it the variable name that we want. So that's just like we did it before with the restaurant, but of course applied to another context. Draw and team1 or team2, just to make sure. And indeed, these are exactly the three values that we have up there. Next up, number 6. So this is going really well. So let's create our print goals function now. Like this, which remember should take in an arbitrary amount of players. And what we mean by that is this. So let me start by calling the function here to make that more clear. So in the test data, it says to use Davis, Müller, Lewandowski, and Kimmich. So just like this. But then, of course, it's supposed to work just the same with another number of players. For example, just these two. All right. And so the way we specify that here in our code is to use the rest parameters. Remember that? So this will then basically aggregate all the incoming arguments into one array. And now let's start by logging here how many goals were scored. And so that is, of course, the length of the incoming players array. So players.length goals were scored. And so, indeed, this first call here gives us 4 goals were scored because we have 4 arguments, and then 2 goals were scored. All right. And then after these examples, the instruction tells us to use actually these values. So this game.scored array. Okay, now we cannot just do this, right? I mean, we can, but it's not going to give us the result we are expecting. So instead, we get 1 goals were scored. And so that's because we only passed in 1 argument. Let's take a look actually at the players to see what I mean. And so the problem here in this last function call, let's take out these 2. So the problem is that now we get 1 array, and in that array is this array with the 4 elements, right? And so instead, we really need these arguments here one by one, right? So we need to take the players out of the array. And I hope that you can see where this is leading. And so we use the spread operator to do just that. And now we are correct. Great. Now we were also supposed to print all the players one by one to the console, but I'm not gonna waste time with that now. We already did that so many times before. Finally, let's now print to the console which team is more likely to win based on the odds variables. So basically these variables that we created here before, team 1 and team 2, which contain these odds. So remember that the team with the lower odd is more likely to win. And so we should now print that to the console without an if statement or the ternary operator. So you can probably guess that we should use a logical operator for that, right? So what we need to test for first is to check if team 1 is less than team 2. And in this condition, team 1 is more likely to win, right? So let's already print that to the console, and then we choose the logical operator, which allows us to reach the goal here. So team 1 is more likely to win. So basically, we want this here to be evaluated when the result of this operation is true. And which is the logical operator that continues operation when the first value is true? Well, it's the AND operator, right? So the OR operator short circuits when the first value is true. And so that's not what we want. So because then right now it would short circuit and this would not be evaluated. But in this case, when this is true, we actually want the evaluation to continue. And therefore, this is the way to go. And so, yeah, team 1 is more likely to win. Now, if the odds were the other way around, let's say here we had 11, then nothing would happen. And so now we also need to do this here another time and do the opposite, basically. So now if team 2 has less than team 1, then team 2 is more likely to win. And so now we get that corresponding result there. Let's put it back. Okay. And challenge completed. So I hope all of this made sense and that it was a great way of reviewing everything that we had done so far. Let's now talk about a new way of looping over arrays, which was introduced in ES6. And that's the for off loop. And let's say we wanted to loop over our entire menu here. So let's start by creating again the array with the entire menu. And for that, we expand restaurant.starter menu and restaurant.main menu. So nothing new at this point. Now you already know how to loop over this array with a regular for loop, right? So you would have to go through all the steps of setting up a counter, a condition, and also update the counter. And that's a lot of work. And so that's why we got the for off loop now, in which you don't need any of that. It's so much simpler. And this is how it works. We still write for, and then we create a variable here. Let's just call it item for now, and then of menu. And then we can log to the console simply this item. So let's see if that works, and then I'm going to explain why it works and what this loop does. So indeed, we got all our elements here now individually logged to the console. So this for off loop, which is called for off because it is for and then item of the menu, right? So this loop will automatically loop over the entire array, and in each iteration, it will give us access to the current array element, which we can specify here. So in this case, it's called the item, but of course we could call it anything that we want. And so if we simply log the current item then to the console, well, then this is here what we get. Simply each element logged one by one. And that's because, again, the item variable is always the current element in each iteration. And also, just like in the if-else statement, we don't need to create a code block when we only have one statement here to execute. Okay, so that's pretty simple, but it's a really nice level of abstraction over the regular for loop. So we can do the same thing with this one, but without having to worry about all the underlying details such as counters and conditions. What's also great about the for off loop is that we can still use the continue and break keywords. And this is important because in the next section, you will learn other ways of looping arrays, and in those one, you will not be able to continue or to break. So you will need to keep that in mind. But now, what if we also wanted the current index and not just the current element? Well, in the for off loop, it's actually a bit of a pain when we need that index, because originally the for off loop was really just meant to give you the current element. However, you can get both, and you will have to do it like this. So for, and then again, let's just call it item. But now instead of just menu, we now need to call the entries a method on this array. So entries, and then let's take a look at the item. And so, as you see, each of the item is now actually an array with the index and the array element itself. So let's quickly take a look at what this mysterious menu.entries actually is. So menu.entries. And so here we get this weird array iterator. And so that's not really helpful, but we will learn about iterators by the end of the course. But if we want to take a look at this, we need to essentially expand this here using the spread operator and then create a new array based out of that. So again, this is really just to take a look at what menu.entries actually is. And so we see that it is basically an array which in each position contains a new array, which contains the element, so the element, and the index number of that element in the original array. And so that's why we get 0, 1, 2, 3, 4, 5, 6, plus all of the original elements of the menu. And that's also the reason why then we get this output from this loop now. Because here we now basically have that array, and so now each item of that array is, well, this new array. And so now if we wanted to like print a nice menu, then we could take advantage of this data now. So let's now log something nicer here. So a template string. So let's take the first element, which is 0, and then let's actually add 1 to it so that we can start the menu at 1. So here we're basically going to display like a nice menu in a real restaurant. And so there the numbers don't start at 0, right? And now here, then the actual item itself. So that's at position number 1. And so that looks quite nice, doesn't it? So this works great here, but we are actually at this point smarter than doing it like this. And that's because if item is now an array, we can destructure it. We don't have to manually take element 0 and element 1. That is the old school way. So let's now do it in a better way. And so we can actually destructure the item array here right here. All we have to do is to use the destructuring assignment and then create the two variables that we want. So let's call it I and EL for element. And so here we can use I and here element. So let's check that. And indeed, it works the same. And so once again, destructuring made our lives a little bit easier here. So it's a really great addition to the JavaScript language here, once again. And the same is of course true for the for off loop itself, which also makes it a lot easier to loop over arrays. So maybe you've been noticing that we have been talking a lot about ES6 features and even newer additions to the language. And so let's continue with that now with yet another enhancement, which is enhanced object literals. And so let's take a closer look at our restaurant object here. So this restaurant object is an object literal. So you can see that because we basically wrote this object literally in our code using this curly braces syntax. So, well, you get the point. So all of this object here has been written using the object literal syntax. Now, ES6 introduced 3 ways which make it easier to write object literals like this. And so let's go through them one by one now. First off, let's say that we have an object that is outside of this object. So let's take this one and create a separate object with it. So const opening hours equal. And so now this is its separate variable. Now here we need a semicolon to fix this error there. But now we still want to have the opening hours object inside of the restaurant. So before ES6, we would have to write opening hours. So that's the property name that we want. And then set it equal to opening hours. And so then basically the restaurant object is restored. Let's see that here quickly. So you see that here we still have the opening hours just like before. Now, the problem here is, and it's not really a problem, but it can become annoying, is that this property name is exactly the same as the variable name from which we're getting this new object, right? And so with enhanced object literals, you don't need to write this. So we can just do this. Let me write this here. ES6 enhanced object literals. And so what this will do now is to take this opening hours object and put it into the restaurant object and create a property name with exactly that variable name. So as we will reload now, then you will see that it's still here just like before. And of course we could change this now, but then we would also have to change it here. Otherwise JavaScript will not know what this variable is. And so now, as you can guess, we have a property called hours. All right, so that's a very handy enhancement. And so let's now check out the second one. So the second enhancement to object literals is about writing methods. So in ES6, we no longer have to create a property and then set it to a function expression like we have always been doing, right? So essentially, we create a property just like we do all the other properties, and then we set that to a function expression. But again, now we no longer need to do that. We can write it in an easier way, which is to get rid of this function, even of the semicolon, and then just like this. And so this now works exactly the same as before, but with a slightly easier syntax. And I actually personally really prefer this new syntax. So I'm going to change this entire object to the new way of writing methods. But this actually comes down to personal preference once again. So if you prefer the old way, you can just keep it like that. So maybe you think it's more explicit if you can actually read the function keyword there. But for me, it's enough that we have the parentheses here. So that alone already shows that it has to be a function. And VS Code itself is also helpful as it changes the color of the methods to green. So VS Code is really smart in that regard. And finally, the third enhancement is that we can now actually compute property names instead of having to write them out manually and literally. And compute just means like calculate. And so let's try that here. So let's say that we had an array with all the weekdays. Weekdays. So Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, and Sunday. And now we wanted to take these property names here out of that array. Okay, so instead of having to write them here manually. So we can do that by using, again, the square bracket syntax. And then in here, we can put any expression, basically. So this was Thursday, so let's say weekdays on position number 0, 1, 2, 3. And of course, we could use the structuring here, but yeah, this is just a demonstration anyways. So weekdays 4, and then here weekdays 5. But let me just show you that we could really do anything here. So we could also compute the name in some other way. Let's just say 2 plus 2 or 2 plus 4. So this doesn't make sense, but yeah, I just want to show you that we can do this. Let's take a look at the object now here, opening hours. And so you see that we still get Thursday and Friday, and then here we get day 6. So we computed this property name using a template literal and then also this expression in here. And this is sometimes extremely helpful to be able to do this. So before we could only compute the values. So here, for example, this could be 12 plus 12, right? But we could not compute these property names, but now we can do that as well. Let's learn about an even newer feature of objects and also of arrays, which is called optional chaining. And this one is really amazing. So let's say that we wanted to get the opening hours of our restaurant for Monday. So let's quickly check that. So restaurant.opening hours. And then, since we are checking for Monday, let's try .mon, so which could stand for Monday. Now actually this property doesn't exist. So you see that this is undefined, right? But let's pretend that we do not know whether this restaurant opens on Monday or not. And that could be the case, for example, if this data came from a real web service, so a web API. And in that service, there could be multiple restaurants and not all of them would open on Monday. And so we had no way of knowing if this particular restaurant would open on Monday or not. But now let's go even further, because we actually want to know exactly the hour on which the restaurant opens on Monday. So let's see what we get. And now we do actually get an error, because the result of this was undefined, and then undefined.open is really an error. So that's the error that we get here. So in order to avoid this error, we would first have to check if this here actually exists. So we could do something like this. If this property exists, basically, then do this. Or we could also use a logical operator, as we already learned, but this here is a bit more readable. All right. So if we did the same for, let's say, Friday, then we already know that Friday exists, and so this would then work, and it would be 11. But let's focus here on Monday, which is the day that doesn't exist. And so now at least we get rid of our error here. So it's not a big deal to having to add this logic here, but it does make our code a little bit more unreadable and more messy. However, this is checking just for one property, so just for Monday. But now imagine that opening hours here would also be optional. Or in other words, that maybe the restaurant object can also not have opening hours. So in this case, we would have to check for both, right? So we would have to do if restaurant.opening hours exists, and if restaurant.opening-hours.Monday exists, well, only then log the opening hours to the console. And this can get out of hand pretty quickly when we have deeply nested objects with lots of optional properties. And sometimes that happens in the real world. And so therefore, ES 2020 introduced a great solution for this, which is a feature called optional chaining. And with optional chaining, if a certain property does not exist, then undefined is returned immediately. And so that will then avoid that kind of error that we saw earlier. And this is how it works. So let's recreate it now with optional chaining. So now we can say restaurant dot opening hours dot Monday, and now here is the optional chaining operator. So instead of just a dot, we use question mark dot and then open. Okay, so here is how optional chaining works. So only if the property that is before this question mark here, so only if Monday exists, then this open property will be read from there. All right, but if not, then immediately undefined will be returned. And exists here actually means the nullish concept that we already talked before. So a property exists if it's not null and not undefined. Okay, so if it's 0 or the empty string, then it still exists, of course. So if we try this now, then we get undefined. So that's exactly what I was saying. And let's just, again, recreate it here without the optional chaining, just to see the error again. And so here we would indeed get the error. Again, because all of this here is undefined, and then we read open here from undefined, which doesn't work. But here, this next operation of trying to read open only happens if all of this here actually exists. So if it's not null and not undefined. But if it is undefined or null, then the result will be undefined immediately. So let's take this out again. And so that is why we get undefined right now. And of course, we can have multiple optional chainings. So let's basically recreate what we have here. So in this example, so here we are testing for both opening hours and for Monday. So these are essentially the two optional properties that we do not know beforehand if they exist. So Monday is optional, and that's why we have the question mark here basically asking if it exists. And now we can do the same for opening hours. And now if restaurant dot opening hours does not even exist, well, then the Monday property will not even be read. And so therefore we don't get that error. All right. And so this makes it really easy to prevent all kinds of bugs that sometimes we might not even expect. All right. So it also takes away all this work of doing this simply by adding this simple question mark in there. But now let's see a little bit more real world example. And for that, let me grab this weekdays array and put it here. Let's just call it days here, so it's not the same variable. And now what I want to do is to loop over this array and then log to the console whether the restaurant is open or closed on each of the days. So that's a good application of optional chaining right there. So let's start just by logging here the day, just so that you can remember how this loop works. And so indeed, now we can do some code with each of these days here. So let's now essentially do the same as we did up here. So restaurant dot opening hours, but now we cannot do this, right? Because this is not an actual property name of the object. And so remember, if we want to use a variable name as the property name, basically, we need to use the brackets notation. So we learned about this way back in the fundamentals section. And so make sure to remember that. Okay. So basically this would be the same in the first day dot Monday and then dot Tuesday and so on and so forth. But the day here is coming dynamically from this array. Okay. But optional chaining, of course, also works with that. And so now we can ask if open exists, basically. And now let's save this to a variable. And then let's log to the console. And this is not yet complete, but for now, let's see what's going to happen. So on day, and then whatever is the current day, we open at, and then here we use the open variable that we just created. Let's get rid of this console.log here. Okay. So we get on Monday, we open at undefined, undefined, undefined. And then indeed on Thursday, Friday, and Saturday, we are open. And so then we get the opening hour that is actually also in the object. Let's just make sure. So this one is open 12, 11, and 0. So essentially it's open 24 hours. It opens at 12 and closes at 24. So at midnight again. All right. So that's working. But now we don't want this undefined here. Okay. And so just like before, let's set a default value. So let's use or. And so as a default, we want to say closed. So we are open at closed. So that doesn't make a lot of sense. So we could create a better sentence there, but let's leave it like this. But maybe you're noticing that now we have a problem, which is that on Saturday it says that we are closed, although actually we open, or the restaurant opens. So here on Saturday, which is this one, indeed, this property exists. So there is a property called Saturday, and so we have a problem here. And the problem is that the restaurant opens at 0. And so here we have the same problem as before, where 0 is a falsy value. And so therefore, it will then trigger this second part of the operator. But we also saw the solution to this, which is to use the nullish coalescing operator. And so that's what we do now. And now we get back to open at 0. Great. So this is an amazing use case of the optional chaining operator and the nullish coalescing operator working together. And in fact, they were introduced into the language at the same time in ES 2020 because they were really designed to work well with each other. So again, both of them rely on this new concept of nullish. And so nullish values are null and undefined. And that's it. And so that's true both for this nullish coalescing operator and also for optional chaining. Okay, great. Now that you understand how it works, let's move to the next topic, which is on methods. So optional chaining does indeed also work for calling methods. So essentially, we can check if a method actually exists before we call it. So restaurant.order, and now we can check if it exists. So we use the question mark dot, and if it does exist, then we can call it. So let's just pass 0 and 1 here. And then we should always use together the nullish coalescing operator. And so method does not exist. So let's run this. But in this case, the method does actually exist. And so here we get the expected result. When we try to call a method that doesn't exist, so let's say order risotto, and so we never wrote a method for that. And so let's see. And yeah, now we get method does not exist. And so just like before, this optional chaining operator will check if order risotto actually exists. And if it doesn't, well, then it will immediately return undefined. And so all of this then returns undefined. And so here in the nullish coalescing operator, we immediately go to that second operand. So that's this one here. And yeah, then that's the result of this whole operation. So of course, if we hadn't this, then we were trying to attempt something that is not a function. So really useful on methods as well. And finally, optional chaining even works on arrays. So basically we can use it to check if an array is empty. So let's simply create a users array in which we can put a couple of user objects. So name, Jonas, and email hello@jonas.io. And yeah, this is just for demonstration, so let's just put one object here. And now to get the name of the first element of this array, we can do this. We can write users element number 0, and only if it exists, so optional chaining, only then take its name. Okay? And otherwise, we want to log user array empty. So let's see. And indeed, we get Jonas. And so again, this optional chaining here tests if the value on the left does exist. So users 0. Okay, so if it was empty, so users, so like this, then we get user array empty. And without optional chaining, we would have to write something like this. So if users.length greater equal 0, then console.log this here. And else console.log user array empty. All right. And so that looks like a lot more work than what we just have up there. So here we don't need to do any check. So that's a lot better. And so now in both cases, we get Jonas. So get used to this optional chaining operator, which almost always we use then together with the nullish coalescing operator, so that we can actually do something in case we don't get a result from the object or from the array that's here on the left-hand side. All right, and with that being said, I see you in the next video. So we learned about the for-off loop to loop over arrays, which remember is an iterable, but we can also loop over objects, which are not iterables, but in an indirect way. Now, we have different options here, depending on what exactly we want to loop over. So, do we want to loop over the object's property names, over the values, or both together? And let's start by simply looping over property names. And so, remember, they are also called keys. Now, ultimately, we will still have to use the for-off loop to loop over the array, but again, we're going to do that in an indirect way. So we're not actually looping over the object itself. Instead, we're going to loop over an array. So let me show you how. So I'm going to call this day, and you will see in a moment why. And now off, and then I say object.keys, and we pass in the opening hours object. And now let's simply, to see what happens here, log the day variable to the console, and then I will explain what happened here. So, indeed, we get Thursday, Friday, and Saturday, which are exactly the three key names of the object. So we can see that here. So indeed, Thursday, Friday, and Saturday. So let's take a closer look at this mysterious object.keys. And let's do that here before, actually. So let's just say properties equal object.keys. And then again, opening hours. And now I want to take a look at the result here. And so indeed, it is an array with the three property names. Okay, and we can actually also use this to now compute how many properties are in the object. So let's say we wanted to print a string saying how many days the restaurant is open. That would be simple, right? We can just log to the console. We are open on, and then properties dot length. And now we get the number of properties here, of course, and so that's 3 days. Okay, and so this is also the array that we're going to be looping over. So properties. And that's why I called this variable here day, because this array basically contains 3 days. Now let's actually do something cool here and instead store this into a variable. And let's say open, and then str for string, and here a colon, because now using the loop, I will basically keep adding to this string. So open string plus equal, and then the current day. So day, and then a comma. And so here we are then essentially building just this string. So that's similar to something we did already before. And so the end is we are open on 3 days: Thursday, Friday, Saturday. Great. So that's property names. Let's write that here. Okay, but what if we actually wanted the property values themselves? Well, then we would simply use object dot values. So let's also store this here. And of course, then we need to pass in the object itself. So that's again opening hours. Missing the equal sign. And now let's just take a look at the values. And indeed, these are exactly the 3 values that we specified right here. So this value here, right? So open 12, close 22, this one and this one, right? So before we had the keys, now we have the values, and there is no need to now loop over them again, because it's going to work exactly the same as here. Okay? But now, to really simulate to loop over the entire object, we actually need the entries. And so entries is basically names plus values together. And we already saw the entries before. So when we looped over the array, and I think that's going to be somewhere down here. Oh, and actually I already passed it. So indeed, here it is. So here on the array, we called this entries method. And so the entries return the index number and the element itself. And so we can do something similar on objects, and that will then also return the key and the value. Okay, now it works differently on objects because it's not going to be a method that we call on the object itself. So here we had the menu array, and then we did that menu array dot entries. But now here we do it differently. So we use again object dot entries, and then we pass in once again the opening hours. So this distinction between the array and the object is important as we loop over the entire object. Okay, I actually run into that problem myself at some point. So that's why I'm telling it to you. But anyway, let's store this again into a variable. And so then you have all the 3 versions here nicely organized in your code. And let's take a look here at the entries now. And so as you might have expected, we now get an array. So all of these keys, values, and entries basically transform the object into an array. And then here we have first the key and then the value. All right. And so now we can use this to basically loop over the object. So for, and now let's start by writing the of. I will just call it x for now, and then we will take a look. So x of the entries that we just generated, and then let's just log them to the console. And so let me get rid of this one here. All right. So that's weird. Oh, it's because, of course, I want to log X. Oh, yeah, that's correct. So now we have each key and each value. All right. Now we want to print to the console a string like this. So on the weekday, and so that is the key. And so I'm using these variables here before I actually defined them. So to make it easier to say what we want to define. So for example, on Friday, we open at, and then we're going to have an open variable and close at close. So how will we do this? Well, just like we did with the arrays, we can use this structuring right here. So let's do that. The first one is the key, and remember the second one is the value. So we could do this, but we already know that this here is an object, right? And so therefore we can also immediately destructure that object here. So fair enough. Open and close. So the two variable names inside of that object are open and close. And so here we specify exactly these property names, and so they get destructured. And therefore this works. So let's see that again. And so, yeah, so this is here the value, basically, all of this, right? And so here we have open and close. And so that's exactly what we defined here as well. And therefore we then end up with the string here, which got all of the data out of the object into this nicely and neat string. All right. So this part here is necessary because the value itself is also an object. But if you had a more simple object with a simple value, then you would of course only do this here as destructuring, just a key and a value. And of course you could then give them other names as you would like. So here we can just call them day. We can use any name that we want. Awesome. So we're doing great progress here. And now it's time to practice that once more. So I see you in the next coding challenge. Let's challenge ourselves with coding challenge number 2. And in this one, we're going to continue with our football betting application. And let me start by saying that this challenge is actually a bit difficult. All right. But that is on purpose. So after all, it's called a challenge. And so you should really challenge yourself with these exercises. Otherwise, it could be called a coding copy and paste, right? So please try your best to solve these. And you can try the problem-solving framework that we talked about earlier. And of course, you can also use Google, MDN, and so on and so forth. Okay? But with that out of the way, let's get into the exercises. And the first one is to loop over the game.scored array and then print each of the players to the console along with the goal number. So this one is not that hard. And so let's just, so the object is down here. So we're going to use the same object, all right? So this is the array that I was talking about. And so here, in this case, we should print Lewandowski goal 1. Then here, goal 2, Gnarby, goal 3, Lewandowski, and goal 4, Hummels. Okay. Then number 2, use a loop to calculate the average odd and log it to the console. And we already studied how to calculate averages, and so you can go check that out if you don't remember. And here you should actually directly use the object itself. So don't destruct the object first into variables and then use that to calculate the average, but instead really calculate the average of the elements in the object. Okay? Then number 3, I want you to print the 3 odds to the console and do that in a nice formatted way like you can see it here. Now here, you're not allowed to hard code the names of the teams, all right? So instead, get them directly from the game object itself. Now, of course, here except for draw, because that's nowhere in the game object. So as a hint, I have here that the odds and the game objects have the exact same property names. And so you can use that knowledge maybe to get the name of the teams here. So these are the three exercises for this challenge, but then I also have a bonus. Now let me just tell you that I will not solve this bonus question in this video because it would take me a little bit too long. But I will still put the solution in the final code of this section, so in the GitHub repository, so you can check out the solution there if you attempt to do this bonus. So this one is really hard, and what I want you to do is to create an object called scorers, which will contain the name of the players who scored as properties. And so Gnarby, Hummels, and Lewandowski were the players who scored in this game. And as a value for each of the properties, we want the number of goals. All right. So this means Lewandowski scored 2 goals and the other 2 players scored just 1 goal each. So this is a little bit difficult again, but you can do it. Well, at least with some research and with some reviewing of all the material of the course so far. Anyway, good luck with this challenge. Take your time, and I see you once you're ready. All right. Hopefully you did at least 1 or 2 of these exercises. And so here goes my solution. And keep in mind once more that my solution might be different from yours, but that's totally okay as long as yours produces the same result. So here the goal is to score over the scored array and print all of the players to the console. So const, and let's again fix that later, and then of game dot scored, and now we actually want the entries. All right, and we want the indexes because we also want the number of the goal. Remember? So goal 1, 2, 3, and 4. Okay, and so entries will give us that. And so now we just need to destructure that into the index and then the player. Okay, actually we don't even need the curly braces. Let's just say console.log and then goal, then the index plus 1 so that it starts at goal number 1, and then simply the player. Let's take a look. Oh, and now we have the problem here that I'm accessing game before it is initialized. And so the problem is that the game is down here. So I will have to take this game object now to that other challenge. So let's just cut it from here and put it here. So now it should work. And indeed, we get the 4 goals nicely printed to the console, exactly in the order in which they appear here. All right, next one. And in this one, we have to calculate the average odd. So the average basically of these 3 numbers here. So what we're going to do is to loop over this object here and simply add all of these 3 values together and then finally divide them by the number of elements here. And so that's how you calculate an average. And so we start by creating the average and set it to 0. And so again, we already did that before, I believe. And so now we can loop over the object such as I explained it to you before. Const odd of, and now what do we actually want? Do we want the keys or the values or both? Well, in this case, we are really just interested in the values, right? And so this object.values will give us an array essentially containing these 3 values. So we need to say game.odds. Okay, and now in each iteration, we will simply add this odd to the average, so that then in the end we can divide it by the length of this object.values array. So let's do that. Plus equal the current odd, and then finally average divided equal, and so this is a new one, by object dot values game dot odds, and then let's log it to the console. So this one here means basically average is equal average divided by this here. And this is actually the same as up here. So let's refactor it into, let's say, simply odds. And then let's use that here. Odds and odds. And we have a problem. So let's do some debugging here. I will start by taking a look at the average after it is computed here in the array. So average. Oh, so here we have a number, which means that something is wrong here in the division, right? And I see it's because we need to write odds dot length. Okay, and so then it will be the number 3 in this case. So before I was dividing by the entire array, and that doesn't make any sense. And so now we should see something close to 4 here. Yeah, so 3.7 essentially. And so that's our result. Okay, and you can go over this code here again if you need to understand it even further. But now let's move on here to exercise number 3. And this time the goal is to print basically the content of the object to the console. So we're going to loop over that. And again, I will first say what we need here actually. So we want to print both the team and the odd. So we need the entire object. And so, just as we learned in the previous lecture, we use object.entries of game.odds. Okay, and so we know that we get an array of arrays, which in each position will have both the team and the odd. All right, so let's say team and odd. All right, and so here it is us who define the variable name because it is now an array. So we don't have to match any property names. And let's start by simply logging both to the console team and odd. Okay, and so indeed, we already have that kind of working. We already have the team here, and we have the 3 odd values. Now what we want to do is to create a string like this. Let's actually copy this so we know what we have to do. And by the way here, notice again what I explained you in the last lecture, how in the array we use the entries method to get the entries of the array, but in the object we have to use object.entries and then pass into the function the object that we are interested in. So that's fundamentally different, so keep that in mind. Okay, so here we now want to build a string like that. So odd of victory Bayern Munich, draw or victory Borussia Dortmund. And so here we're going to need some more logic. Let's just put here some dots. And now here the odd. So the odd is the easy part. So we have that one already finished. But now here we need some more complex logic. And actually let's create this part of the string. So like victory Bayern Munich or Borussia Dortmund or draw. Let's create that here in a separate value. So let's call this one team string. And so here what I'm going to use is to use the ternary operator. Okay, so I will say that if the team here is X, like we have it here, then the string should become draw. And so that will then create this here. So team equals X, then the result should be draw. But if not, then we need the team name itself. So how will we get that? And remember, there was a hint about this. So note how the odds and the game objects have the same property names. And indeed, here we have team 1, team 2, and here we have team 1 and team 2 as well. And so here are the team names. And so let's now get these team names using these keys that we already have here. So we want the string victory. And then we go to the game object and team. Let's check. Now I know, of course, we need to put that string here. So team string, and it works. Beautiful. So let's just recap this part here. So here we go into the game, which is the entire game object, and we take the property team. But team is already this property name here, right? So it's team 1 or team 2. And so then we take that to read the property with the same name from the game object. And so therefore we get Bayern Munich and Borussia Dortmund. Okay, great. So this one was a little bit more tough, but we managed to do it in the end. Now again, I will not create the solution for the bonus, but you can always find it in the final code of this section. And with that being said, let's now go back to learning some more JavaScript. In the past, JavaScript has always had very little built-in data structures. So basically, we only had objects and arrays. But in ES6, 2 more data structures were finally introduced, and that are sets and maps. So these are pretty common data structures that already exist in other programming languages, and now they also exist in JavaScript. So in this lecture, let's learn all about sets. And a set is basically just a collection of unique values. So that means that a set can never have any duplicates, and that property makes them useful in certain situations. So let's create a new set here. Let's call it orders set. Okay. So again, to create a new set, we write new set, and then here we need to pass in an iterable. And the most common iterable here is an array. So let's create an array with a couple of strings now. Let's say pasta, pizza, then pizza again, then risotto. Let's put another pasta and another pizza. Okay, so 6 strings, but of course they could be different data types in here. So set can of course hold mixed data types. That's not a problem at all. Now here we clearly see some duplicate strings. So what do you think that this set will look like now that we created it and when we log it to the console? Well, we get a set. Here we can see it has a size of 3, and the only values that are in there are pasta, pizza, and risotto. So that's right, all the duplicates are actually gone. Now also we can see that a set kind of looks similar to an array, right? So there are no key value pairs, it's just a bunch of values grouped together, in this case, into a set. And just like arrays, sets are also iterables, okay? Now, of course, a set is still very different from an array. So first, because its elements are unique, And second, because the order of elements in the set is irrelevant. And we will see why in a second. But anyway, keep in mind that strings are also iterables. So we can do this. So we can pass in a string. And so now we get a set with these 5 elements. So, and that's the 5 components basically of this iterable, which is this string. And of course, the set could also be empty, just like this. All right. And now let's learn how to actually work with sets. So first off, we can get the size of a set. So order set.size. And so that is 3. And so in this particular example, this might be useful for the chef of our kitchen to know how many different meals are going to be cooked here. Right? So if this array here is an array of all the orders, then the set of these orders are simply the unique different meals that are going to be cooked. And then the size is how many different meals will be cooked. And just note how it is actually called size and not length like it is in arrays. So don't make that confusion. Next, we can check if a certain element is in a set. So order set.has, and so this is actually a method. And so let's check if pizza is in there, and let's check if bread is in there. So true and false, and that's exactly as we expected. And so comparing again to arrays, this has method is similar to the includes method in arrays, right? Next up, we can also add new elements to a set. So order set dot. So let's say that now someone ordered garlic bread. And let's say that this actually happened twice. So what do you think that the set will look like now? So order set. And so the garlic bread got added, but only, of course, one of them, because again, the set has to be unique. And so the second one was basically ignored. Finally, we can also delete elements. So let's do that before the log. So order set.delete. So all of these method names are very straightforward. And that's because this is such a modern feature. So the modern stuff really has this more straightforward names and a different way of working with the data structures. So we have risotto here, and so now here we are deleting it. And so indeed, it is now gone from the set. So really, really easy. And in arrays, there's actually no method that is this simple. We will see how to delete elements from arrays later, but I can tell you that it's a little bit more complex. Okay, and that's actually it. But now you might ask, how do we actually retrieve values out of a set? Can we maybe use an index like in arrays? So doing something like, maybe like this here. And the answer, as we will see, is no. So this doesn't work. It gives us undefined, no matter what number we put here. All right. And that is because in sets, there are actually no indexes. And in fact, there is no way of getting values out of a set. And if we think about this, then it makes sense. So there's really no need for getting data out of a set. That's because if all values are unique, and if their order does not matter, then there is no point of retrieving values out of a set. All we need to know is whether a certain value is in a set or not, and that's why we have the has method. If your goal is to actually store values in order and then retrieve it, then the best use case is to just use an array. You wouldn't use a set for that. And so again, there's no need for getting values out of a set, because if you need it, then you would just use an array. Finally, there is actually one more method here, but it's not that important. All we can use it for is to basically delete all of the elements of the set. And so we see that now it is empty, right? But let's put that back so that we can work some more with this set. So as I said in the beginning, sets are also iterables, and therefore we can loop over them. So let's say order from orders set, and not from it is of, obviously. And then we can just log the order, and indeed, here they are. So looping is possible just like in any other iterable. All right, so now that we know how to work with sets, let's see a big use case for them right now. So in a normal code base, the main use case of sets is actually to remove duplicate values of arrays. So let's just write that here, example. So let's say that we have an array in our restaurant which contains the stuff of our restaurant. Let's say we have one person that is the waiter, one person that is the chef, another person that is a waiter, then we have also a manager, then we have another person that is a chef also, and another waiter. So that's an array of all our stuff in the restaurant. But now let's say that for some reason we are interested in knowing only which different positions there are in our restaurant. Or in other words, we would basically like to have a unique array of this, right? So this array without all the duplicates, that will solve the problem. So let's create a set for that. Easy enough, right? So stuff unique equals new set, and then the iterable that we need to pass in is the stuff, because an array is already an iterable. Now this is not yet the end of the solution, but let's take a look at it for now. And of course, it needs to be stuff unique. And so, yes, so we have a set now with waiter, chef, and manager. So the three unique positions. But now we actually want this to be an array. But the conversion from a set to an array is pretty easy because they are both iterables. So remember from earlier that the spread operator works on all iterables, right? So that includes sets. And so we can now create an array around this basically, and then we can unpack this entire set here using the spread operator, and then these elements will be put into the newly constructed array. Okay? And so indeed, we now end up with a new array. Okay? So the spread operator here works just like on an array. It works really exactly the same. So it takes all the elements out of the iterable and essentially writes them here like comma separated, right? Now, if we only wanted to know how many different positions there are, then the size property is very useful. So all we would have to do, even though this looks a little bit weird, would be to say new set, then with the array, and then dot size. And that's it. And then we wouldn't even need to have to create the array at all. So if we didn't need the unique array. So if all we had was this, and we wanted to know how many unique positions there are, then this here would be the way to go. And the same could even be done with counting how many different letters there are in a string, right? Because an iterable, or actually a string, is also an iterable. So let's see how many different letters there are in my name. And it looks like there are 11. All right. So as a conclusion to this video, sets are not intended to replace arrays at all. So whenever you need to store values in order, and that might contain duplicates, always just use arrays. That's also true when you need to really manipulate data, because arrays have access to a lot of great array methods that we're going to study a little bit later. Now, sets have this very useful property of being unique. And it's also very easy to interact with sets by using all of their straightforward methods. However, they are not nearly as important as arrays. So keep sets in mind when you need to work with unique values, but besides that, you can just continue using arrays. So we learned about sets. Now it's time to learn about the other new JavaScript data structure, and that is maps. And let me start by telling you that maps are a lot more useful than sets. So what exactly is a map? Well, it's certainly not the same thing that we use in the real life to find our ways around. No, instead, in JavaScript, a map is a data structure that we can use to map values to keys. So just like in objects, data is stored in key-value pairs in maps. Now the big difference between objects and maps is that in maps, the keys can have any type, and this can be huge. So in objects, the keys are basically always strings, but in maps, we can have any type of key. It could even be objects or arrays or other maps. So that can lead to some really great and advanced stuff. So let's create a restaurant map here. So I'm just calling it rest here. And so we again use the constructor just like we used for the set, but this one called map. And the easiest way to create a map is to actually create an empty map just like this, without passing anything in. And then to fill up the map, we can use the set method. And then here we pass in two arguments. The first is the key name. So let's call it name, and then the name of the restaurant itself. So Classico Italiano. And so you see that this set method is pretty similar to the add method that we had in sets. So both allow us to add a new element to the data structure. And remember that we can use any data type that we want. So let's say that the restaurant has two locations. So we can create a key with a number. It doesn't have to be a string. So let's say one is in Firenze, Italy, and the other one, so a number 2, is in Lisbon, Portugal. And calling the set method like this does not only update the map that it's called on, but it also returns the map. So let me show that to you here. Okay, so this is what the set looks like after adding this key number 2. So here we have the entries. The first is name, which is then mapped to Classico Italiano, and then the other two that we just added. Now, the fact that the set method actually returns the updated map allows us to chain the set method like this. So let's set categories here as an array, and I will just grab that from up here. Okay, so once more, the value can be anything. And now I can just chain the next set on here. So I can now say open and set it to 11. And then again, I can chain the next one and say close at 23. So let's save it. And this will then format this nicely. So again, calling the set method returns the updated map. And so all of this is now the updated map. And so we can call set again on that map. And we can continue this even further. So let's now actually even use Booleans as the key here. And we can say that we want to map true to we are open. And then we can also set false to we are closed. And we will see in a minute how this can become useful. Okay. Now, in order to read data from a map, we use the get method. And so that get method is available on all the maps. And so all we need to do is to pass in the name of the key. So let's see. Let's log this to the console actually. And let's just duplicate it here and also log true. And you see that the true key here is then mapped to we are open and named to Classico Italiano, of course. And here, when we get the elements, of course, the data type of the key matters. So if we tried true the string, then that would be undefined. And if we tried to retrieve 1 as a string, that would also be undefined, because here we have 1, the number, as the key. And so with this, we will then get Firenze, Italy. All right. Now, just for fun, let's use the fact that we can have Boolean keys. So this true and false here, right? And we also have the open and the close time. So you see they are all kind of related. And so let's create something fun with this. So let's say we have some current time, and we could actually get the current time from JavaScript, but we don't know how yet. So let's just say it's 21 hours. So that's 9 p.m. And then we could do something really clever like this. So rest.get. And so when we pass in true, then we will get we are open. And when we pass in false, we will get we are closed. And so in order to get the correct string here according to the time, all we need to do is to compare the current time with these two open and close. Okay? So let's do that. We can say, or we can ask, is the time, so the current time, greater than rest.get open? And at the same time, is it below rest.get close? So basically here we are asking if the current time is between 23 and 11. And so this here is a true-false value, and this is a true-false value, so a Boolean. And so the result of this AND operation will be either true or false. And then true or false will map to one of these values. So that's really clever, right? So let's log the result to the console, and let's check it out. And so at 21 hours, we are open. And that makes sense. It is between these two times. But if it was like 8 hours, then we are closed. Amazing. Now this is, as I said, pretty clever, but it's not really so readable. So don't overuse this kind of pattern, okay? This just really goes to show the power of having Booleans as map keys. But anyway, let's now keep exploring the methods that are available on maps. So we already have methods to set and to get. Now we can also check if a map contains a certain key. So let's log to the console the result of calling the has method. So categories. And so this should be true. And it is indeed true. Then we can also delete elements from the map, and again, that happens based on the key. So rest.delete, and let's say that the second location should be closed now. So this one here, the one in Lisbon. And so we take that key and delete it from the map, and as a result, that will then be gone here. So you see, no longer there. Now, comparing this to objects, we can actually also delete properties from objects using something called the delete operator. But that's a really slow process, and usually it's not encouraged to do that. Here about the has method, actually objects do also have a method, which is called hasOwnProperty, but we're going to talk about that in the object-oriented programming section. All right. Next, maps also have the size property. So rest.size, of course, and that should be 7, as we can see here. And yeah, so it has 7 items. And then to finish, we can also clear, so basically remove all the elements from the map. Let's just put that here. And so now it's gone and it has a size of 0. Let's put that back. So as you can see here, there is some overlap in the way that we work with maps and sets. And that's because they were both introduced in ES6. And now just to finish, let me show you that we can, in fact, use arrays or objects as map keys. So let's here set something else. And so now as a key, I will use this array. And I will set it to test. Okay. And let's just put that actually here, so it's before the log, so we can take a look at it. And so here indeed we see this is now the key, this array. All right. But now to get the data based on that array, let me see how we could do that. So rest.get, and think about what we are doing here. Do you think that this will work? And actually we need to log it to console. But given what we learned in the previous section about how JavaScript works behind the scenes, especially primitives versus objects, do you think that this will now retrieve test? Well, let's see, and no, it did not. And the reason for that is that these two arrays are actually not the same object. So this array and this one, even though we wrote them in the same way, and so they have the same elements, they are not the same object in the heap. Okay? And the key here is exactly this object in memory, and not this one. And so this cannot work. In order to make it work, we would have to do this. So creating an array, 1, 2, and then we use that array. And then we also use the same array to read the value out of the map. And so now it is gonna work. Okay, because now, of course, these two refer to the same place in memory. Great. And so with this, we proved that we can indeed use objects as map keys. And this can be very useful with DOM elements, which in fact are also nothing more than just a special type of object. Let's do that here as well. Let's do rest.set. And now as a key, we will use document.querySelector. And then we're going to select this h1 element that we have here. So this is just an h1. So nothing fancy. And so the result of this will be an object. And so let's say that this is the heading. And now as we check it out here, you will see that it is here indeed. So as I hover it, you can even see it here visible on the web page. You see that? The highlight up there? That exactly is the key of this map entry. Sounds crazy, but it is possible, and it can enable some advanced functionality. All right, so we learned here how to create maps and how to work with them. So this should be enough for one lecture. And so let's wrap up this one now and continue learning about maps in the next one. So let's continue learning about maps. So in the last video, we created an empty map and then added elements to it by using the set method. Remember? However, there is actually another way of populating a new map without having to use the set method. And I prefer that because the set method is a bit cumbersome when there are a lot of values to set. So instead, we can create a new map like this. So I'm going to call this one question, because now we're implementing something like a quiz. So in a very simple way. So new map, and then here we can pass in an array. And this array itself will contain multiple arrays, and in each of these arrays, the first position is going to be the key, and the second position is going to be the value. So let's do that. So let's say question, and then what is the best programming language in the world? So this is basically the first entry of this question map. So before we would have used the set method and then this as the first argument and this as the second. But now we can simply specify this array of arrays in this way. Now, next up, I want to specify the options for the answer basically. And so I can simply do that by their number. So the first answer is going to be C. So C, the programming language. The second will be Java. And the third will be, of course, what else? JavaScript. Then we need a key for the correct answer. And what do you think the correct answer is? Of course, number 3. And then we can also have like a success message and an error message. And so let's again use the Boolean keys. So true, which is basically when the user is correct, then we can say correct. And maybe some kind of emoji here, like this one. But if it's wrong, so if the answer is false, then try again. All right. And so let's take a look. And that looks correct. Fantastic. So when creating a new map from scratch directly in the code, I actually prefer this way of writing it over the way that we did in the previous lecture. But when we keep adding new elements programmatically using code, then of course the set method is still the way to go. Now, as an aside, does this kind of structure here, so this array of arrays, look kind of similar to you? Well, I hope it does, because this is exactly the same array structure that is returned from calling object.entries. So for example, on the opening hours object. And so you see that there too, we get an array of arrays, where the first element is the key and the second one is the value. And so what this means is that there is an easy way to convert from objects to maps. So let me write that here actually. Convert object to map. And so we can say hours map is a new map, and then simply with object.entries of opening hours. All right. So again, because this structure that results from object.entries is exactly the same as this. So an array of arrays. So indeed, now we have a map here. And so keep this small trick here in mind whenever you need a map when you already have an object. Next up, let's talk about iteration. And iteration is possible on maps because, as we already know, maps are also iterables. And so the for loop is also available for them. And so let's use a for loop actually to now print just these options here to the console. So these 3, all right? So, as always, I like to start with first saying what we will loop over. And so that's going to be the question map. And so each item of the question will, just like before, contain both the key and the value. And so here I can now directly destructure that into two separate variables. So this is a really, really good use case of destructuring. All right. So just to reiterate, this is exactly the same as we did when we looped over the object. The only difference is that for the object, we needed object.entries right here. And that's just because the object is not an iterable. But then we converted it to an iterable using object.entries. And so then this part here is exactly the same. Okay. Now keep in mind, we only want to print these three. So essentially, we only want to print an element if the key is a number. So let's use what we already know. Type of key equal number. And only then log to the console. So inside here, answer, and then the key. So the number for the person then to choose with the correct value, which is going to be the answer option itself. So here we go. Answer 1, 2, 3. And now let's just also log the question itself. So quiz app. And here we want question.get, remember, and then the question key. And so now it is complete with question and answers. Now to get the answer from the user, let's again use a prompt. So answer equal prompt. And let's ask for your answer. And answer. And remember, we need to convert this now to a number, because eventually we will compare this number with the key that we have here. All right. Let's just print it then also. Okay, so here we have the question, and of course the correct answer is number 3. And so here we go. And now we can use the power of the Boolean keys here in order to print either the success message here or the error message, basically. All right. So do you think you can do that on your own? Just take a minute or two and try that on your own right now. So did you manage to do that? Well, let's start by comparing the answer with the correct answer, basically. So that is question dot get correct. And so this is 3, right? And then we can compare that to the answer. So in this case, this was also 3. And so this here would return true, correct? And now since this is true, we can directly plug that into the map. And so this true will then return correct. So that's similar to what we did in the previous video as well. And so again, we are using the power of having Boolean values as keys. And then let's just log that final message to the console. So 3 again. Oh, and something went wrong. But I see that it's just here. It's the name. So this is correct, not correct. So again, 3. And now indeed we get correct. Okay. So this is 3 here. The answer is 3. This is 3. And so this here will be true. And so when we get true from the map, we get this string. Now, something else. And indeed, we get try again. Okay, and with that, we finished this nice little quiz. Now, just to finish here, as a side note, sometimes we also need to convert a map back to an array. So basically to this structure. And we can do that like this. So convert map to array, basically. You can do that by simply building a new array and then unpacking, again using the spread operator, the question map. It's asking us here again. And so then the result is essentially this same data structure, so the array of arrays with which we started. So it's this one here. So in this case, of course, this wouldn't make too much sense, but it's still good to know that sometimes you can convert a map to an array. Let's just preset this here to some value so that it doesn't always bug us here. And by the way, there are also the methods that we had on arrays, which are the entries and also keys and values in case that you need them. Okay, now they give us this weird iterator here. So then, just as I showed you before, you have to spread them and put them in a new array. So like this. But this is not really that important. I just wanted to show you that this exists. And for this, there's actually no need because it's going to be exactly the same as this one. Okay, so these are all the keys and all the values indeed. All right, and that's all I have to show you about maps for now. But now you might be wondering, when should I use maps and when should I use objects? Because they are pretty similar, right? Well, that's what the next lecture is all about. There I will help you to choose between all the data structures, including even arrays and sets. Dealing and working with data is the main thing that we do as developers. And that's the reason why, since the beginning of the course, we have been working with JavaScript's built-in data structures like arrays and objects. Then in the last few lectures, we learned about two new data structures, which are sets and objects. So now we have 4 data structures from which we can choose. And so I decided to create this quick lecture, which will show you the pros and cons of each data structure and also when to choose each of them. And I want to start this video by quickly categorizing where data can actually come from. So there are essentially 3 sources of data. First, the data can be written within the program's source code itself, like status messages that will be displayed on a web page based on user actions. Second, data can come from the user interface, so from the web page. It can either be data that the user inputs into some form or data that's already written somehow in the DOM. For example, this can be the user's tasks in a to-do app or expenses in a budget app or anything like that. Finally, data can come from external sources, which is usually a web API. Now, what is a web API? Well, API stands for Application Programming Interface, and we can basically use a web API to get data from other web applications. For example, we can use a web API to get the current weather in any city, or data about movies, or currency conversion rates, and really every kind of data that you can imagine. And we will learn how all that works later in the course. So no matter where the data comes from and what kind of data it is, we usually always have collections of data that we then need to store somewhere. And so where do we store collections of data? That's right, we use data structures. But as you know, there are 4 built-in data structures in JavaScript. And so now we need a way of deciding between them. But it's not that hard. So the first decision is this. Do we just need a simple list of values If so, then we're going to use an array or a set. But on the other hand, if we need key-value pairs, then we need an object or a map. So the big difference here is that with a key-value pair, we have a way of describing the values, so by using the key. On the other hand, in a list, like an array or a set, we simply have the values without any description. Okay? Now, as a quick example, let's go back to getting data from a web API, because in modern JavaScript applications, that's usually the most common source of data. So data from web APIs usually comes in a special data format called JSON, which looks like this example here. So JSON is essentially just text, so a long string, but it can easily be converted to JavaScript objects because it uses the same formatting as JavaScript objects and arrays. So here we have three objects that describe recipes. We have the values in green, like the title and the publisher, and it makes complete sense that these values are then described using a key. Otherwise, we would have no idea what the different values actually are, right? So key-value pairs are essential here, and that's why this data is stored in an object, not an array. Now, each of these recipe objects in itself can be seen as a value, and since we have many of them, it means that we have again a collection of data, and therefore we need a data structure to store them. Now, do we want to describe each of the objects? Well, it's not really necessary, is it? We already know they are all recipes, and whatever information we need about the recipes is already stored right in each of the objects. So all we want is basically a simple list where all the recipes are held together. And so here, an array is the perfect data structure for that. And in fact, creating an array of objects is extremely common in JavaScript. Now you will be working with this kind of data all the time as a professional JavaScript developer. And that's why I'm placing so much focus on this here. Okay, now before we move on to compare arrays, sets, objects, and maps, I quickly want to mention that there are also weak sets and weak maps data structures in JavaScript. Also, there are even more data structures that are used in programming, but which are not built into JavaScript. And just to mention a few, these can be stacks, queues, linked lists, trees, or hash tables. And these don't really matter for now, but I still just wanted to let you know that there are more than just the 4 built-in data structures. But now let's talk a bit more about the built-in data structures. So you already know at this point how to use all of them, but it's important to know when to use them. So starting with arrays versus sets, we already know that we should use them for simple lists of values when we do not need to describe the values. Now, you should use arrays whenever you need to store values in order and when these values might contain duplicates. Also, you should always use arrays when you need to manipulate data because there are a ton of useful array methods. Now, sets, on the other hand, should only be used when you are working with unique values. Besides that, you can also use sets in situations when high performance is really important, because operations like searching for an item or deleting an item from a set can be up to 10 times faster in sets than in arrays. Now, one great use case for sets is to remove duplicate values from an array like we already did before. So sets are really not meant to replace arrays, but rather to complement them whenever we are dealing with unique values. Okay, so now let's talk about objects versus maps, and we already know that we should use these key value data structures whenever we need to describe the values using keys, right? But when to use objects and when to use maps? Well, objects have been the traditional key value data structure simply because we didn't have maps before ES6. But using objects simply as key value stores has a couple of technical disadvantages. And that's why some people say that we've been abusing objects for this. Now, maps, on the other hand, are way better suited for simple key value stores, because they offer better performance, in fact. Also, map keys can have any data type, and they're also easy to iterate, and it's easy to compute the size of a map. However, the biggest advantage of objects is probably how easy it is to write them and to access data by simply using the dot or the brackets operator. Also, most developers are already super used to objects, and so they simply keep using them for simple key value stores. Anyway, as a conclusion, you should use maps when you simply need to map keys to values, and also when you need keys that are not strings, because as we saw in the last video, that can be very powerful sometimes. Now, if you need functions as values, then you should absolutely use an object for that. So in objects, these functions are then called methods, and you can use the this keyword to access properties of the same object, which is impossible in maps. Also, when working with JSON data, as we saw in the previous slide, you will probably be using objects for that as well, unless you then want to convert the objects to maps. But that's usually not something that we do. So, in fact, we still use objects all the time, but maps are also a very important data structure right now, and way more important than sets. Great, and with that, we wrap up this overview. I hope you found this useful, and so let's now move on. And now it's time for coding challenge number 3. And we are still working on our football betting application. Now this time we have this map down here, so this one, which contains all the events that happened during the game. So the values here are the events themselves, for example a goal or a substitution, and the keys are the minutes in which the event occurs. And just notice that a football game has 90 minutes plus some extra time. So this might be a little bit over 90, but usually it's always 90 minutes, in case you're not familiar with this beautiful game. Anyway, your tasks are to create an array called events, which will contain all the different game events that happened during this game. And that means no duplicates in that array. Now, after the game has finished, it was found that the yellow card from minute 64 was unfair. So please just remove this event from the log. Next up, print this string to the console. An event happened on average every 9 minutes. And of course, your task is to calculate this 9 minutes, keeping in mind that the game has 90 minutes. Finally, loop over the events and then log them to the console. And what's tricky about this is that you should mark whether they happened in the first half of the game or the second half. And the second half means that it happened after 45 minutes. So it should look something like this. So I believe that this challenge is a little bit easier than the previous one, and so hopefully you can manage to complete all of these 4 tasks. So I see you once you're done. So I hope that was fun. So let's get started immediately with the solution here. So we should create an array called events with the unique events. So basically, that's the unique values of all of these here. Now, what are these values here? They are essentially the values of this map, right? So what I'm saying is that they are game events dot values. And we learned about this one kind of by the end of the last video. So let's comment out this one here. And so indeed, we see that this is what contains the values that we are interested in. All right. So let's say game events dot values, and this is our starting point. And now to get the unique values here, we basically need to create a set out of this, right? That's the main use case of sets. So new set, but this alone is not going to be enough, but let's still take a look at this for now. And beautiful. So indeed we have a set with the only 4 events that happened. So there were only golds, substitutions, yellow cards, and red cards. And now to convert this to an array, we do it just like before. Create a new array and a spread operator to unpack this set. And then we are done. Next up, this one is the easiest one. So it tells us to delete the event from minute 64. So that's very easy. So game events dot delete. And now all we have to do is to use that exact key, and then that event will be gone. Great. The next one is just as easy, I believe. So let's just grab this from here. And now we just need to calculate this actual average. And how do we do that? So basically, to say that an event happened every X minutes, we simply need to divide the number of events by 90 minutes. So the duration of the game. So we see here that we have 3, 6, 9, 11 events. So how can we count that programmatically? Well, for that we have game events dot size. Remember? And now we just divide that by 90. And with that we get this weird number. And that's because, in fact, we need the opposite. So we need to say 90 minutes divided by how many events there happened to say that on average something happened every 9 minutes. Now, if we wanted to be really specific, then this game actually lasted 92 minutes. So how do we get that value? So this is just a bonus. Okay, I didn't expect you to do this one. So this 92 is essentially the last of the keys of the map. So let's get the keys. So that's game events dot keys. And as always, we need to convert this to an array. So using all the tools that we already learned. So just to make sure, indeed, it is. And now we want the last value. And how can we get the last value? Do you remember that? Well, we can use the pop method. And in the past, we mainly used the pop method to simply delete the last element of the array. But also back then I told you that this also returns that deleted array. Or actually that deleted element. And so here we can take advantage of that. So this here is an array now. And so on that we can call pop. And so that will take the last element out of the array and give it to us. So that's 92. And so to make this really accurate, here we can now say time. Okay, and so this is even better right now. But again, this is just kind of a bonus just to show you some more nice little tricks. Anyway, now our goal is to loop through the object, or actually through the map. And so this is pretty standard now at this point. Now here we are missing the off. So just like we did in the last video. And now all we need to do is to figure out the half. So if it's the first half or the second half. So what we want to log to the console is this, and then so either first or second half, and then the minute, I believe, let's see. Yeah, so the minute and then colon and then the event. So let's actually make these here more specific. So minute and event. So that makes it easier to read the code. So minute and event. And now here let's just again create an external variable, which I'm going to call the half. And let's use the ternary operator here again. So if the minute is below or equal 45, then it is the first. Otherwise, it's the second. And that's it. And that worked just fine once again. Okay. So I hope that made sense. In case it didn't, then as always, just analyze the code, or you can also just ask some questions in the Q&A area. Anyway, we're now almost done with this section. Next up, all we have left to do is to work with strings, which is also a really nice and really interesting topic that we need in JavaScript all the time. So make sure to follow me there right away. Over the next few lectures, we will learn how to work with strings. And so we're going to be taking a look at a couple of useful string methods. Now, I could have divided this part about strings into many more lectures and go really deep into some topics, but I think it's best to just quickly introduce you to all the topics here and then keep using them in future projects, because we work with strings all the time in JavaScript. And so you will see these methods being used all the time throughout the rest of the course. Anyway, this is going to be really fun, so let's get started. And in this part of the section, we're going to leave the restaurant theme behind and work on stuff related to airplanes and airlines. So that's something that I really like. So let's now start by creating an airline variable here. And I'm using TAP Air Portugal. All right. And if you want, you can use some other one from your country maybe. But then you might have to adapt the examples. So as a plane, I'm using a string A320. Okay. And now let's do some stuff with this. So just like in arrays, we can get the character of a string at a certain position. So for example, plane at position 0 should be A, right? So let's load this here, and indeed we get A. And the same, of course, for all the other letters. 1, 2, for example. And so indeed, you now get 3 and 2 here, but both of them are still strings. So if we wanted them to be numbers, we would have to convert them. And we can do the same directly on a string. So we can just write a string, and let's write B737 now, which is a Boeing. And so this works the same. Okay, so now we got the B. We can also read the length property of strings, just like we can in arrays. So let's say airline dot length, and again we can also do that directly on the string. Okay, there you go. Next up, let's talk about methods. So again, comparing strings to arrays here, strings also have methods, and some of them are quite similar to the array methods. So one of them is the index of. So I believe we talked about this one when we talked about arrays. And so this one works the same way. So we can get the position in which a certain letter is in the string. So let's use R here. And so here we now get the position number 6. And so let's see, 0, 1, 2, 3, 4, 5, and 6. Okay, and that's where this 6 here comes from. So you see that strings are also 0 based, right? And we could observe that already up here. Now this here will only give us the first occurrence, but sometimes we might need the last one. And so then we can use last index of. Last index of. And so that is 10. So this one was 6, then 7, because the space, of course, also counts as a character, then 8, 9, and this is position 10. All right. And we can also search for entire words. So, for example, for the occurrence of Portugal, and so that is at position 8. And this one is actually case sensitive. So if I search with lowercase, then we get -1, because this can now not be found in this airline string. All right. Now, what can we actually do with these indexes? Why are they useful? Well, one good use case is to extract part of a string using the slice method. And the slice method needs indexes as arguments. And so therefore, sometimes it can be very useful to first figure out the index of part of a string to then extract that. So let's see how the slice method works. So airline and then dot slice, and let's write 4 and see the result here. All right, so the result is Air Portugal. And the reason for that is that this here is the begin parameter. So basically it's the position at which the extraction will start. And remember that this is 0 based, so 0, 1, 2, 3, and 4. So 4 happens to be this A, and so this is where the slice method starts to extract. And now this result that we get here, so just this here, is called a substring, because it's just a part of the original string. Now this does not change the underlying string, okay? Just keep that in mind. That's because it's actually impossible to mutate strings. They are primitives, right? So if we wanted to use this string now, we would have to store it first into some variable or some data structure. Okay, so this method here and all the other ones that we're going to talk about always return a new string. Okay, and so that's why we can then log that result to the console like this. Now, besides the begin parameter that we already specified, we can also specify an end parameter. So let's try 7 and see the result. And so now we only got air. Okay, so this one is 4, then 5, 6, and 7 is the space here. And so what this means is that the end value is actually not included in the string. All right, so basically it stops extracting before reaching index number 7. And that's really important to keep in mind. And just as a side note, the length of the extracted string is always going to be end minus beginning. So 7 minus 4 is 3. And so that's the length here of air. All right. Okay. Now, up until this point, we have always just hard-coded these values. But of course, many times we don't even know the string that we receive yet. Okay? And so let's now try to extract just the first word of this string here, but without knowing any of the indexes. And so that's where this index of and last index of here become really important. So basically that we do not have to hard code these values here. All right, so let's try to extract that first word, as I was saying. So airline.slice, and now we need to figure out the index. And now if we want the first word, we need to start at 0. But what about the end parameter? Well, we want to extract until this space here, basically. So let's find the index of that. So airline.index index of, and remember that this will be the first occurrence, and so indeed we get top. All right, and now let's do the opposite, extracting the last word, so slice. And so for the last word, we want to start at the last space here. Okay, that's why we have last index of. So airline dot last index of, and again searching for the space. And now we don't need the end parameter because then if we don't specify it, it will simply extract everything until the end. Okay, but actually now the space is also included here. And so we just need to add +1, and now we're good. So that's the fundamentals of the slice method, but we can do even more with it. So let's go again here, and we can even define a negative begin argument, like this, for example, and then it will start counting from the end, or actually start extracting from the end. So these are the last two letters from Portugal. And finally, let's duplicate this one again. And again, I'm using this shortcut here for duplicate. Okay. So we can also specify a negative end parameter. So the begin is back to positive, and now the end is -1. So let's see. And so basically we started at position 1. So that's why the T is cut off. And then the negative end parameter basically cuts off the last character. All right. And so we will need all of these different combinations here in different situations. So it's good that you know how to use them because you will need them at some point. Okay. And now let's practice a little bit what we just learned and write a function that receives an airplane seat and logs to the console whether it is a middle seat or not. So I hope that sounds like fun. So let's write check middle seat, and it is a function which takes in a seat. And just to illustrate it, let me start by calling this function. So check middle seat. And so typically an airplane seat looks like this. So we have the row as a number here, and then the seat itself, so that's like the column, so to say, is then a letter, for example, a B. So it starts from the left and goes all the way to the right side. And in small planes like the A320 or the Boeing 737, we only have 6 seats in one row. And that means that B and E are the middle seats. Let me just write that here. B and E are middle seats. So just in case you're not familiar with how these small planes work, right? And that's also not the point here, of course. So basically all we want to do is to check if the string that we receive contains a B or an E. And if so, then it's a middle seat. And let's call this with a couple of different strings. So 23C and 3E. All right. So what we need to do here is basically take the last character of the string and test whether it is a B or an E, right? So let's get that letter from the seat. Now we'll just call it S for seat again, but I cannot repeat the same name here. So how do I do that now? Well, to extract part of a string, we already know we use the slice method. And how do we take the last character of a certain string? Well, we use -1 as the begin character. And then, as we saw up here, it will start counting basically 1 from the right side. And now it's very easy. If S equals B, or if S equals E, then let's log to the console. You got the middle seed, which is the one that no one wants. Well, let's add an emoji here. Let's say this one. Or else you got lucky. Just any emoji here, just to make it different. And I think we are good now. Let's test it. And so indeed, this here contains the B at the end. And so therefore it's a middle seed. The same for this one. And this person with this seed got lucky. All right. And that's how we extract parts of strings. And that's something really important to do. So maybe if you'd like, you can play around with this some more, maybe come up with your own example. Now, before we move on here, let's just stop for a second and understand why all of this actually works. So we know that strings are just primitives. So why do they have methods? Shouldn't methods only be available on objects such as arrays? Well, that is actually true. However, JavaScript is really smart. And so here is how this works. Whenever we call a method on a string, JavaScript will automatically, behind the scenes, convert that string primitive to a string object with the same content. And then it's on that object where the methods are called. All right? And this process is called boxing because it basically takes our string and puts it into a box, which is the object. So basically, what happens is this. So what JavaScript does is to call this string function here. Okay, and so now you see that this string here looks a little bit more like an object. And we could take a look at this here. And so you see here all of these methods like slice that we just used. But this is beyond the scope of this lecture. We will learn what this is a little bit later. But what matters is that this indeed is now an object. So you see, it is an object. And so this conversion here is what JavaScript does behind the scenes whenever we call a method on a string. And then when the operation is done, the object is converted back to a regular string primitive. Okay? And in fact, all string methods return primitives, even if called on a string object. So let me demonstrate this here as well. Just really quick. And actually we want here type of. And so the result of all of this is then back to being a string. Okay, but don't get confused by this. This is just the theory explanation behind why all of this works, in case you're curious. And I hope you are. Great, but now let's move on to the next video where we will continue working with strings. Let's continue with some simple string methods. And the first two are going to be for changing the case of a string. So that's airline dot to lowercase, and this doesn't require any arguments at all. And then we also have to uppercase, and these we use all the time, as you will see soon in a more real world example. And here you see that indeed they transformed the string all to lowercase and to uppercase. And again, you can of course call these directly also on a string. So like this. All right. But now let's use this on a more practical example to fix the capitalization in a passenger name. In name. Okay. So let's say that the passenger, when he checked in, misspelled his name. And so it looks like this now. And so this needs to be fixed. It should look like this. Okay? So in order to fix it, the first step is usually to put everything into lowercase here. So const passenger lower is passenger dot to lowercase like this. Okay, so basically we already have now this part here, and now all we need to do is to essentially take the first letter and then the rest of the string and put these two parts back together. So passenger correct will be passenger lowercase, and here we only need the first letter. So how do we do that? We take the first letter by using the index 0. And so this one we now convert to uppercase. All right. And now we simply need to add the rest of the string. So again, we take passenger lower, and then we use the slice that we learned in the last lecture and start at position number 1. Because remember, that will then go to index 1 and take everything until the end of the string. And so here we then put back together just the first part of the string converted to uppercase here, and then the rest of the string that we already had converted to lowercase before. Okay, and indeed, now it is corrected. Great. And of course, we could have done a function with this. And so maybe if you have the time, you can do that. So just create a function which takes any passenger name and then returns the correct one. So with the fixed capitalization. But anyway, I will now do another real life example, which is to check a user input email. Okay, so check email. Now this will not be really a checking, it will more be a comparing. So comparing emails. So let's say that we have the email of one passenger. So hello@jonas.io. But now as the user logs in, so let's say login email, accidentally they do it all wrong. And they start with a couple of spaces here. And then the capitalization is all completely off, like this. And then maybe even another space, or even an enter character, which remember is \n. So I think we talked about that in the beginning. Okay. But still, this email here is actually still kind of correct and kind of valid. And so we can now still compare if these two are kind of the same. Okay, so we can now try to convert this one to this one and then check if they are the same. Because essentially, again, they are. They would be different if we had like different letters here. Then of course they would not be the same. But here it's just a matter of capitalization. And for emails, I believe that they are still valid even with the capitalization off. And so when we check user input like this, the first step is usually to convert it to lowercase. So lower email is login email dot to lower case. And then we must also get rid of all the white space here. So these empty spaces and also this enter basically here also counts as a white space. So there is even a method for that. So let's say trimmed email, and so that is lower email dot trim. All right, let's just now log this to the console just to see. And so that looks exactly like that first version. Now just look closely at what we did here. So we called to lowercase on this login email, stored it to this variable, and then on that variable we called the trim method. But why do we even need this intermediate email? We could do this all in one step. So basically we can replace all of this, and let's call this normalized email actually. And so again, I will start from login email and then do it all in one step. Dot to lowercase. And now this is a bit similar to what we did before with the map set method. So this here will return a new string, right? And on strings, we can call string methods. And therefore, right here, we can now immediately call the trim method. Okay, so normalized email, and that should look exactly the same. And it does. So let's get rid of this. And these two I will simply leave as a comment here. And now just to finish, let's actually also compare them for the sake of completion. And once again, you could do this here in a separate function. So you could do a function for this behavior where you pass in two emails, one which is the correct one and one which is the one to check. And then you could return either true or false from that. So again, that sounds like a good challenge that you can take if you want. And by the way here, since ES 2019, there's also trim start and trim end, which as their names say, you can use to trim whitespace only from the start of the string or only from the end. Next up, let's learn one of the most important things about strings, which is to replace parts of strings. So replacing, okay? And we're gonna stay here again with the airlines. So let's say we have the price of a flight, and that price is for Great Britain. So let's say 288,97 pounds. And you can use any other currency sign that you want here. What's important is that here in Europe, we use the comma as a decimal separator, unlike in the US, where you use the period, so the dot. And so that's actually what we're gonna do now. We want to compute the price in US. All right. And so for that, we will need to replace the pound with the dollar sign and the comma with the period. So that's easy enough. Price Great Britain dot replace. And now here two arguments. The first one is the one we want to replace. And let's start here with the pound sign. And the second argument is the string that will replace the first one. So let's take a look. Price US. And so that already worked. And now we need to replace also the comma with the period. So we could create another variable now, but instead we will do chaining again, just like we did before. And for the same reason, because this returns a string. And so on that string, we will immediately call the next replace method. And now we are replacing the comma with the dot. And so, indeed, now we have the price in US. Okay, but indeed, we can also replace entire words, not just single characters. So let's create an announcement that you would typically hear on the airport, like all passengers come to boarding door 23. Boarding door 23. However, usually it is called gate and not door. And so let's replace that and log the result to the console immediately. Because just like the other method that we studied, replace also creates a brand new string. It doesn't mutate the original one. And so here it's the same. And so we need to log the actual result to the console. So replace door with gate. And here it's boarding. And now let's check it out here. So here, boarding gate, but then here you actually still have boarding door. And so this replace only replaced the first occurrence of this search string here. Okay? And actually that's completely normal. That's just how it works. But we can still go around this. Now very soon JavaScript will have a method called replaceAll, which will work like this. But right now here it should not work yet. And indeed, I get here replaceAll is not a function. But if you're watching this video in the future, then this here might already work for you. So please go ahead and try it out. All right, but for me it doesn't work yet, but there is still another solution, which is to use something called a regular expression. Now, regular expressions are one of the most complex and confusing topics of programming, but we will still take a short look at them at some point in the course. But for now, we are just going to use a very simple regular expression to tell the replace method that it should actually target all the occurrences of door here and not just the first one. So let's again copy this here. And then to create a regular expression, we need to write the string between slashes. So not between quotes. So it turned yellow here again, which means that it's some kind of string, but it is now a so-called regular expression. Then in this case, all we want to do with this regular expression is to add this G flag here. And this stands for global. And that's actually it. So right now, all the occurrences will be targeted. And so we replaced gate here and here. All right. And just as a side note here, once more, the replace method is of course also case sensitive. So just like all of the other string methods are. Okay, and now as a final topic of this lecture, there are three simple methods that return booleans. So booleans, okay? And these methods are includes, starts with, and ends with. So let's create a new plane here. And that's going to be the A320 Neo. And I'm just missing here the assignment. And now we can simply use includes just like we can in arrays one more time. So they have a very similar structure here in terms of methods that we can use on them. So includes, and let's test if it includes the string A320. And indeed it does. So this airplane here is the Airbus 320 Neo, but it still includes just the A320. Now, let's say if it includes Boeing, and of course it doesn't. And now there's another one, which is the starts with. And this one is also actually very much used. I remember using it very recently. And so in this case here, it is false. All right. But then if we change this here to Airbus, then it is indeed true. Okay. So these three letters here are indeed the first three also here. So it doesn't have to match the entire word. So just AI would also be true, but AI B, let's say, would then be false. Because of course the string does not start with these three letters. With Air B, then it would again be true. Okay? And of course this A320 is also still true as long as it is somewhere in the string. So now it's somehow here in the middle. Okay? So let's try something very simple here. So let's say that we want to check if the current plane is part of the new Airbus family. And so all we need to do to check that is to see if the plane name starts with Airbus. And we can already confirm that it is, right? And we also need to check if it ends with Neo, because that means that it's part of the new Airbus family. And so we can also use ends with. So as always, these methods here that return booleans are especially helpful for conditionals like this. Part of the new Airbus family. And indeed, this one here is. But of course, if it was just the regular A320, then that would not get logged to the console. So whenever you need to take some decision based on the contents of the string, these three methods are very, very helpful. And let's now actually practice that a little bit with some kinds of, we can say a practice exercise. And so here we want to check if the baggage of a certain passenger is basically allowed to be checked in. So to be allowed on the plane. So check baggage function. And then here we get the items. And let me again first call the function to show you what I mean. So basically the passenger here says what they have. So I have a laptop, some food, and a pocket knife. Then let's call this again and say we have, or I have some socks and a camera. And then let's call it a third time with the string now, got some snacks and a gun for protection. Okay. So maybe some passenger would bring a gun to a plane. But so now let's make sure they will not get aboard the plane. And actually, let's change some things here. So let's make this uppercase. Let's say this person likes to write uppercase for some reason. Okay. And so this is important to show you once again that when we receive input from a user, we usually always start by putting everything into lowercase. Okay. Because that makes it a lot easier to then compare it to something. Well, let's simply say baggage here. And so baggage is basically items to lowercase. So this one we use all the time. And now we can just check if the baggage includes a knife or a gun. And in that case, the person is not allowed on board. So if baggage dot includes, and so here is that method again, which returns a boolean. So if it includes knife, or if it, so baggage includes a gun, then we say you are not allowed on board. Else, let's log welcome aboard. All right. And so now let's see here why it is so important to convert everything first to lowercase. So in this example here, this first person has knife, but with an uppercase. And so if we didn't convert this to lowercase, then this includes here would be false, because the lowercase knife is different than the uppercase knife. Okay, so let's see the result. And so indeed, this person has a knife, so they are not allowed. This person here is fine. And then this one has a gun. And so, of course, they're also not allowed. But now, if we took away this here, well, then our code is not really going to work. So let's just delete this part for now. So if we didn't have the two lowercase, then the first person would also be welcome aboard. And again, that's because knife here, uppercase, is different from this knife. And so then we would have to check for all the variations, like knife like this, or this knife, or even this. So every possible variation. And so that would be highly impractical. And so we just turn everything to lowercase. So again, so that we can then easily compare it with one standard, which is this and this. All right, perfect. So that was another fun lecture, if you ask me, and I hope you are feeling the same. Now it's time for a break, and I see you back here in the next video.